right, let's explain PHOSIMP filters 31 to 40. So 31 is obviously just panning the image, and this is actually modifying the image, right? 32 is going to pan in the other direction, and once again, this is actually modifying the image. This is not like some type of software pan. I'm actually applying a filter, right? So then we have like 33 here, right? 33 is going up, and then 34 is going down. So 31, 32, 33, 34, pretty obvious what they do, right? So 31, panning in this direction, 32, panning in this direction, 33, panning in this direction, 34, panning in this direction. Pretty obvious, we can move on. Okay, so 35 is what is known as the Space Invader filter, and it's variant number 1. So now if we use it a whole bunch of times, the image kind of decays into complete chaos, and things don't really look very good after that. Filter number 36 is also a Space Invader filter. I believe there's about 4 or 5 or 6 variants. I'm not sure. I can't remember. So 36, Space Invader filter as well. 37 is another Space Invader filter. 38 is another Space Invader filter. And then 39 maybe. I don't know. 39? Yeah, 39. Okay, I probably rounded it up to 40. So 40 is probably a Space Invader filter as well. Oh no, 40 is something different. 40 is definitely something different. Okay, so let's talk about the Space Invader filters. So first of all, are they distinct? And they should be, right? So 36 here should look a little bit different than 37, right? And 37 should look different than 38. And 38 should look a little different than 39, right? Now, if we use them multiple times in a row, like if I use 36 multiple times in a row, the way this decays should look different than the way the other things decay, right? So 36 a whole bunch of times, right? Okay, so how about 37 a whole bunch of times? Okay, boom, 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 okay. So that is a lot different. That is a lot different. In fact, that almost looks like it just down-res the image. Let's use 37 one more time. Okay, we can kind of see we have some interesting symmetric patterns here, but then when we use it again, it almost just kind of down-reses the image. Okay, but it did something different, right? The point is it did something different, right? 38, if we use 38 over and over again, the image is decaying in a slightly different way than with 36. Almost, the things kind of almost look like they're moving in the opposite direction. Like the flow is different. Doesn't it look like this is flowing to the top right? Whereas like 38 is flowing to the bottom right. And then 39. Okay, 39 here. Use that a few times. Okay, this one kind of dissolves, but this one kind of dissolves to white. Whereas 36 is kind of dissolving to kind of a black, right? Okay, so how does the Space Invader filter even work? Well, one way we can kind of show it is that we can use 36 a few times, right? And then after we've used 36 a few times, we could zoom in with 605, right? And see what we're looking at. And you can see that we have a whole bunch of very small cells of symmetrical designs, right? Like each one of these things is a little small cell of symmetrical designs. So the idea of the Space Invader filter was to scan through the image and make very tiny kaleidoscopes, right? The exact way that it makes kaleidoscopes is kind of complicated, but the basic idea is scan through the image and turn every single small chunk of tiles into a tiny kaleidoscope. That's basically what happens with the Space Invader filter, right? So I'm not sure why this one is kind of down-resing the second time we use it. What we could do is, that's Space Invader filter 37. If we blur the image a little bit, and then we do 37 again, and now we do 37 again, oh, that's interesting. It's still kind of ended up down-resing even after I gave the photo a little bit more resolution by blurring it. That's kind of interesting. So we can, I want to mess around a little bit more with PHOSIMP filter 37 here, the Space Invader filter. I don't know why this one is breaking down into pixelated patterns, but let's use 36 on top of that. Let's mess around with this. Let's just do something kind of interesting, right? Okay, let's 366 to soften it up. And 366 is not what I wanted to use, but now we're here, so let's break that up into something. 377 is what I wanted to use. 300, and then 37 was that Space Invader filter that... Okay, 377, soften it up. Soften it up. Put a floor on top of that. Okay, I kind of like that, right? It's very noisy. It's very noisy, but it looks different from what we've made before. So I think that we will ship this. Okay, so I'm gonna go look at the logs for how we made this, and this will be one more thing that kind of ships with PHOSIMP. Now, if you look at this, it looks like a kaleidoscope, but if you pay close attention, you see that the top and bottom of the image are not completely symmetrical, right? You kind of see this little bar here and this longer bar right here. I guarantee if we look at the left and right sides, they are probably not perfectly symmetrical either. So like I can see that this bar here has a little green dot in it, and this bar over here does not have that little green dot in it. You see how like it at a first glance it looks like a kaleidoscope where I just mirrored the image 4 times, right? That I just mirrored it bilaterally on both the X and Y axis, but that's not actually what's happening. And when you closely inspect, you can see that's not what is happening. So one of the goals of PHOSIMP is to make it so that I can create what I call a non-naive kaleidoscope. Okay, so we're going to take this stuff and we're going to go put it into this file called recipe.txt here. And we see that it's under 60 steps, or under, well, it is under 60, but it's under 64 is the important thing here. We're going to save this, and we're going to go into our other piece of software here, and we're going to load this recipe in. So we're going to go to a customization slot. I'm just going to use any customization slot on the bottom, and we are going to import the recipe.txt, and then we're going to run it. Now, we're running it on a different image, right? So what we want to make sure here is that when we run this recipe on a different image, that we still get something interesting looking, right? That we still get something where it's like, oh, that's pretty cool, right? Now, I will say that this kind of looks kind of clown barfy, right? And the other one did look a little bit clown barfy as well, right? So you see how we have 2 images. They have the same kind of feel, but they're obviously different, right? So now that we have that, and we know that it gets something interesting with those 2 different images, I'm pretty confident that no matter what I put in, we're going to get something interesting. But we can try with one more image just to make sure that indeed it makes something with the feel of the image on the left. So we'll use another image. Now, all right, how do we feel about that? You know what? I feel okay about that. It's a little bit chaotic and scattered, and I don't like this that much. But the point is that it is different than what we've made in the past. Okay, so what we're gonna do now is we're gonna save the recipe out to a text file and overwrite what we exported. So sorry, we imported and then we re-export, and we do that because now these numbers are nicely formatted. We can get rid of these zeros, right? We don't need the 0 padding, right? We just need the part of the recipe that actually matters here, right? So this is the part that matters here, right? So in our faux face code, the next available slot is 271. So we're going to go back here and we're going to look for slot 271 on the main menu. Here's 271. We want to run 271 and make sure that it doesn't actually look interesting. 271 is just random numbers, but every once in a while those random numbers do something interesting. Here, no, not interesting, not cool. So we know that we can take these numbers and we can completely nuke them, and this will be another recipe that goes into faux face so that people can have an easier time making cool things, right? So we'll do that, and we'll go find this recipe. We'll get rid of these extra spaces, right? And then we will put this right here. Bam. Okay. And now we need to format this a little bit better, right? So these numbers have leading zeros in front of them, which makes them octal numbers. And we actually want our numbers to be kind of these 4-digit numbers, but they're not decimal numbers if they have zeros in front of them. So we're going to do this little hack where we made macros for every single filter number. And there we go. We got to get rid of this lax comma right in the front. But now we have this recipe embedded into the source code. So now what we're going to do, I'm going to call this bad tutorial space invader zoom. So the reason I'm going to call it bad tutorial is because I know that these steps, like I should do some of these steps that better demonstrate what the Space Invader filter does. And this kind of demonstrates the Space Invader filter, but it doesn't do it very well. So this is my display name. Now I'm not trying really hard on these display names because it's like, how do you name abstract blobs? And you can't really, there's no real good way to do that. So let's not try too hard, right? Just throw something in, right? Bad tutorial, Space Invader. Right. Okay. And so this is a recipe. This one here is recipe 271, right? Okay. So I have pretty high confidence that this recipe is embedded into the source code properly. So the next empty slot is 270. So I'm going to look at 270 and see if 270 looks interesting or not. I've seen something like this before. Nope, not liking it. I got a lot of like randomized slots that make something like this. So even if you think this looks cool, there's a whole bunch of randomized slots making things that look very similar to this. We don't just want the recipes to be different, we also want them to be distinct. Where if you look at this and then tomorrow you look at another filter, you should be able to know absolutely certainly that they were different effects. If you have to do two different effects and you have to put them side by side or flip between one and flip between the other to know that they're different effects, then they are too similar and they shouldn't be in here. Okay? Now, obviously, if you use the same effect on two different photos, if you saw one of the images on one day and one of the images on another day and you couldn't tell the difference, that's fine. But if you put them up against each other, they should be obviously different, right? So there's different kind of threshold rules depending on what we're doing, right? These different numbers should all be very distinct from each other in terms of the output they get. And then when we use the same recipe on two different images, the output should also be different, right? So the output for any one of these recipes should be visually distinct so that if I look at the different recipes throughout the course of multiple days, I'm absolutely certain they're different, even though I'm not doing a side-by-side comparison. They should be that distinct. And then when I use the same recipe on two different photos, it should be distinct enough that when I put them side by side, I instantly tell the difference, right? Okay, so 270 is a reasonable slot to override. And the reason I want to do that is because the Space Invader filter 37 decays into noise. So 36, I'm thinking we do 36, and then we could do 605 to zoom in, and then we could do 36 again, and then we could do 605 to zoom in. Actually, there's another zoom that goes in the top left. So 605 and then top left is 607. Okay. So I want to remember that 607 because I'm thinking 37 and then we're going to go 605 to zoom in and then we're going to use 37 and then we're going to go 607 to get that top left quadrant up there. And then we're going to go 1111 to kind of interlace that. We're gonna blur this vertically. We're gonna put a gradient ramp on it. We're gonna use filter 38, which is another Space Invader filter. Okay. Then we're gonna do filter 11, which kind of tiles things and unintentionally is somewhat lossless. And then we could zoom into that, right? We could zoom into that pattern with 605, right? Because that is kind of interesting. I know we're losing data that way, but that looks interesting to me, right? And then we could stop there, but I'm not going to. I'm going to put another gradient ramp on it. And then I'm going to do a 300. And then I'm going to do a 605 again. I'm going to zoom in one more time. And then I'm going to do a 377 to soften that up. And then I'm going to do a 300. And then I think I'm going to call that a day right there. I think that looks pretty cool. I know I used 300 way too much, but I'd say we've made something kind of interesting, right? So if we go move this around with 33 here, boom, 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 right? Just move it around to make absolutely sure that it does perfectly tile. I'm not going to check the other axis. I'm confident that the other axis will tile as well. So now that we've done this, we're going to go look at our logs. And our logs are, okay, so this is PHOSIMP. Here's our logs. And we see can't compare like that in C. So this is basically where our reset button starts. And we're going to grab those. We're going to copy those. We're going to go into recipe.txt right here. We are going to paste. Okay. Then we're going to clean this up right here like that. And then we're going to save that. And then we're going to go into, looks like we have to rebuild PhoFace because we keep on getting this resize viewport code error, client size wrong. We need to address this eventually. So I'm gonna I'll do that off camera because it keeps on happening to me. I need to fix that. But right now, let's not worry about it. Right now, we don't want to ship with it that way. It seems like when the window gets like minimized or hidden, the program crashes. We can't be publishing like that, right? So we gotta get that fixed. So what we're gonna do is all the steps we did to get to this pattern, which is pretty cool looking, right? We're going to embed this pattern into PhoFace so that it's easier for you to like recreate this, like if you like what you see, right? And I'm hoping that will make PhoFace a little bit easier to use in some regards. I know that my software is kind of like this alien technology where, you know, it's never going to be super easy to use because I'm just doing very strange. Oh my god, did we crash it again? Okay, that really blit area, not 5. Okay, that's another error. Okay, and that was in Gothicu, huh? Okay, so over here we're gonna. Okay, we gotta fix a lot of that. So a lot of those error messages are just because my error checking code is like overzealous, and I'm guessing that depending on the size of the window, it's not possible to. I probably inset the canvas inside of an oversized window, but if the window is not oversized and I try to inset, then I can't get a blitting area that's 512 by 512 for my user interface, right? My user interface has this minimum size of 512 by 512, and if I go under that, it looks like it's causing a crash. Now, I should probably also test with this to make sure this is not built on the reusable user interface library that I'm using for the other game. Okay, let's move this over here. Let's remaximize that. Okay, so we're going to go to customize. We're going to use just some random empty slot. We're going to go import, and we're going to take that recipe, and we're going to run it. And remember that this is a different image, right? We're starting with a different starting image, but we just want to make sure that we get something that has a similar feel, right? Now I'm saying that, you know what, that is totally different. That is totally different. It still looks kind of cool though, right? This looks pretty cool compared to that, right? So I'm okay with shipping it, right? The chaos of like how different the results can be, that chaos is part of the fun, in my opinion. So we want to, because it is so chaotic though, we definitely do want to run a few different images in and just make sure that no matter what we get, we think it looks cool, right? We don't want to do it with something and then be like, you know what, that's super lame. And like right now, I'm kind of seeing that kind of like, mostly we're getting this panel effect. Like somehow we got lucky here, right? Okay. So I'm okay with that. I'm okay if that most of the time it gets that kind of not that cool looking look. But sometimes you get lucky. I'm fine with that. That's acceptable. Okay. So I do want to try with a few other images and see if I can ever get something that looks cool. It's just basically that when we were zooming in with the original image, we were zooming into areas that already had detail, right? So maybe what we want to do is make some type of zoom effect that actually zooms into the quadrant of most contrast, like a smart zoom, right? This looks interesting, but it's still not as intricate as this, right? So back to main menu. Let's go load something else. So far, we haven't really got anything else that looked really cool, have we? We just kind of like, it's all looked kind of like meh, right? So let's try. Where was that? I lost it. It was a meme. Where are you, meme? We try this dog. Okay. Okay, let's run it on the dog. Okay. So you can see that there's these areas of more and less interesting detail, and if we zoom into the area that doesn't have as much interesting detail, we get this kind of more panel-looking effect. Okay. Let's go. Yeah, so I definitely, as I'm doing this, I definitely think it'd be nice to have a zoom effect that zooms into the area of most visual interest. Okay, this possum might have transparency on it. No, it's pre-matted with the... Yeah, it doesn't really have transparency. Okay, let's go. We're going to use this. Okay, customize. Okay, so you can see that there's these big white areas that don't have much interesting detail, and if we accidentally zoomed in one of those... Okay, so for the most part, we just get these weird panels, and sometimes we get lucky here, right? Where this is much more interesting. So, but I definitely think this would be interesting for like an animation where like you do this recipe on every single frame of like a video, and then every once in a while we get this weird pattern emerging out of these panels, right? So I still think this looks cool, and I'm still gonna put it into PHOSIMP, but we need to save a few of these to demonstrate why I want another filter. Like I've been forgetting to save these after I run the filter. Okay, so let's use Bird Girl. Okay, so let's go customize and go run this. Now this is a really blurry photo with like a lot of white sections in it. So like, right, so we're not zooming into this area. We're zooming into the top left the first time. So I don't know if this is actually going to get anything interesting. Oh, no, we zoomed into the center first, and then we zoomed top left. So we can see that this does not look as interesting as this, right? I am going to save this one, though. So we're going to go find the bug folder. And we're just going to, where is the bug folder? Maybe I shouldn't have named it with kanji, because I can't type the kanji. Here's the bug folder. So, new folder, filter idea. I'm just going to name this filter idea. And I'm going to go 002.png. And this one right here, we're going to save this as well. And this might open up a different folder. Filter idea 001.png. And then let's go back here. Let's go, I know this is probably boring because it's like, okay, let's go load one more image so I can kind of demonstrate how we get so many different outputs. How about this cat with a burger? Okay, let's go to the customize menu. And back to main. Where the hell did I accidentally flip through here? I probably did. Yeah, there's our 290. Okay, let's run this. And then I haven't seen something as interesting as what's on the left yet. And that's fine. Okay. So we'll go save this as well. And put it into the bug folder. Where is our bug folder? There it is. This will be 3. Okay, so we're going to go, so this recipe right here, we're going to re-export it, right? We're going to re-export it, and we're going to find that recipe.txt. Is it not here? Oh, because I got to change this thing to not filter for just PNG files. Okay, save that. Yes, I want to replace it. Okay. So now if we go look at our text file, right, reload it, right, we got these nice numbers here, right? I'm going to get rid of this. I'm going to take these numbers right here. And I'm going to put them into the source code. We already kind of determined that this looks like bullshit, so the numbers are going to go in here. This little marker here, we're going to put up here. And then we're going to sanitize this data a little bit, right? We're going to clean it up. Because right now, these are not the actual... These are octal numbers. They are not... Well, some of them are octal. If they start with 0, they're actually octal numbers. And we want them to all be decimal numbers. So we use this little hack with these macros we created to turn them into decimal macros. So 0037 will now be decimal 37, right? Okay, so then we need a dynamic Dan's choice zoom. So right now the Dan zoom filters, you know, are preset to zoom into the center, the top left, the top right, the bottom left, or the bottom right, right? We need some type of dynamic Dan's zoom that kind of chooses what to zoom into based on what has like the most interesting contrast or detail, right? That could lead to less smooth animations if we apply the filter to like a video, if it's like making these logical choices on big sections of the image. But for the output of a single image, it'll probably get more interesting results if we can focus on the areas of highest contrast or sometimes lowest contrast, right? So now that I have this little marker here, I'm actually going to go need dynamic Dan choice zoom. I'm actually going to put $signs around this because I actually don't want to forget about this, right? So I'm going to like put some notes in here about like what I'm talking about. Okay. I noticed that this new recipe only really gets very cool results with the PHOSIMP default image. And that makes sense because when I was looking at the image and deciding what sections to zoom into, I decided to zoom into the most interesting subsections of the image. There are 5 Dan zoom filters. 605 zooms into the center. 606, 607, 608, 609 zoom into the individual 4 quadrants of the image, right? Let's make sure that's true. 606, 607, 608, and 609, right? Is that true? Right? So, let's go 606, top left. Oh, wait, no? Oh, outward. 606 is out. So 605 is inward, and then 605 is out. Okay. So it's 607, and then it's going to be like 609. 607, 609. Okay. So I'm wrong there. It's 607, 609, 611, and 613, right? So 613 should be the bottom right, right? So if we go refresh this and we go 613, bottom right, right? And then 610 is going to be the bottom left, right? Or not 610? What do we put on our notes? Oh, 611. 611. Okay. Okay, so the reason why right? So the reason why there's this weird spacing here is because right, 605 zooms in, 606 zooms out, right? They're both doing the center, but one goes in and out, right? So we might want to call this, instead of put center at the end, we might want to go zoom center in and out, right? So we know, yeah. Okay. So then we'll pair them, right? And we know there's 4 more, right? There's 607, there's 608, there's 609, there's 610, right? There's 611, there's 612, there's 613, there's 614, right? Did we get that right? I feel like we got that wrong. 7, 8, 9, 10, 11, 12, 13, 14? Really? Oh, okay, yeah, that makes sense. So 6, 13, and 14. Let's do that for a second. So 6, 13, and then 6, 14 is going to zoom out. Now you see that when we zoom out, right, we don't get the original image, right? Well, now the reason we don't get the original image is because once we zoom in, we lose that data, right? So that's that. Okay, so the faux face recipe. So the faux face recipe 270. Would be right? So these are the different options we could have. And this zoom center, obviously these are not correct. So I'm going to rewrite this. And the reason I'm going to rewrite these is, well, first of all, I cut and pasted them and they're wrong. And the other reason is the way my token highlighting works, I want it to be quicker to see the pattern in the documentation. So what I mean by the pattern in the documentation, well, we'll explain that after I get the pattern in the documentation. Okay, so now, like, if I touch this, right, I see this light up over here, but then I also see down here light up, right? If I touch this, I see the 2 individual sections lighting up. So I'm explaining all of these filters here, and then I'm saying it would be interesting if we had something that decided to do those 5 things, decide to do this, 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 or this, or this, depending on the contrast, right? Zoom center in, right? Always inward though, right? Not outward, always inward, right? The options, all options, always inward. Though maybe another Dan's choice. Okay, so now that we have kind of this kind of random rambling, what we're going to do is we're going to take our images and our little tag, and we're gonna go to the Discord server, and we're gonna make a note of this. So we're gonna go open up Brave. And before we open up Brave, though, we might want to close this because Brave is gonna like take up way too much. I like this. I'm gonna keep that open, right? Brave is memory leaking my... Okay, never mind. Okay, oh my god, never mind, so hard. Oh my god, okay. Never mind, never mind, never mind, never mind. Chrome and all the goddamn Chromium browsers. I only have 8 gig of RAM. I can't have you memory leaking on me every time I open you. So we're not going to do that right now. Hopefully I just remember to do this. Another thing we can do is we can do like at filter idea. Right, we can just add that and maybe give us a fighting chance of like finding this in the future. And then in Kanji Coder PHOSIMP, this is where all the filters will be programmed. This Steam release is not done yet, so I don't really want to... This will be another thing on the plate. I'll make a little note that infoface.c11, we have a Dan choice. This is going to be too long of a tag, so what we'll do is we'll say Dan choose filter, right? We'll call it the Dan choose filter. And this thing that says Dan choose filter, we're going to go back into PhoFace, and we're just going to double label this, so usually, like, if I grab onto something, right, it'll bring me somewhere else. But that's not going to happen because I'll do this, like this, so that at least I can kind of bounce back and forth to know that I'm actually searching. And this Dan choose filter thing right here, right? If I go copy that and I go into Kanji Coder PHOSIMP and I go Control F on that, right, I'm going to find this. Okay. So that's just, I just want to keep track of, like, when I have some insights, I want to make sure that I don't forget to do those insights, right? Okay, so we liked this recipe, 37605. And that is, we already put that in the code, right? That is 37605, blah, blah, blah. Yeah, okay. So we're going to go 271 really quick. We're going to go find where the 270 is, right? Okay, so 270. We need a dynamic Dan zoom. I don't know exactly what I called it in the commentary at the bottom of the file, but that's what I'm going to call it because it's going to remind me that, hey, I need to do this, right? We don't have it, but we need it, right? And this filter is an example. We need a dynamic Dan's choice zoom. We need a dynamic Dan zoom. Yeah, that's fine. Okay, so as I'm kind of messing around in PHOSIMP, I'm like, hey, this 613 and then 614, that looks kind of creepy. I like it. Why don't we mess around with that a little bit, right? So let's do that. And then 1113. So this actually has a very close to the Space Invader effect of what we were doing earlier. But it's much more regular than the Space Invader filter. Somewhere we have like a pixel shuffling filter. I think it's like in the 500s or 600s somewhere. I don't know exactly. So I'm gonna just like, I'm just gonna spam some stuff. And I think, unfortunately, we zoomed in on some stuff. So I'm not sure how I feel about that. That's kind of cool. I kind of like that. Okay, so now that we have something else that we kind of like, right? It's a little bit chaotic because I kind of lost track of what I was doing. Didn't we type like a number that was way too high? Oh, no, 1,188 is actually not too high. I thought I went too high. Okay, so we're gonna take these numbers here, and we're gonna go recompile PHOSIMP here because it keeps on crashing on us, and we're gonna put this recipe into. Oh crap! We kanji coder PHOSIMP. We oh, because this is a multi-line comment. We can't do this because we're already in a multi-line comment. So we can do that though, because we're already in a. The reason I didn't know is because my my syntax highlighting is all fucked, right? Because like we know, like if we go redo our syntax highlighting, right? I'm like, oh, this isn't a comment. Yes, it is. Yes, it is a comment. My syntax highlighting is just broken, and because my syntax highlighting was broken, I literally typed the wrong thing because my syntax highlighting was broken. There we go. Yeah, okay. So we have that recipe we just put on our clipboard. Let's put it into here, and let's trim down these numbers. Okay. And then once we have PHOSIMP compiling, we're going to shove those numbers into PHOSIMP, and we're going to see if we get something kind of interesting like this, right? Okay. So we're going to move that over to the side. We're going to go to Customize, and we're going to go Import that recipe. And then we're going to immediately run it. And this is not, oh my god, that's not the right thing. Wait, is it? No, it is. Okay, maybe it is this. Okay, so let's make sure. So what we can do here, right, we can load in the image that we used in PHOSIMP, right? Okay, if we run this, we should get exactly this. If we don't get exactly this, then the number sequence is not what I thought it was. Like we did something wrong. Okay, wait, maybe. Nope, 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 nope. Okay, yeah. So that's not. That looks cool, but it's not. It's not the number sequence, right? I don't know what the hell we did. So going in, we still have the logs, right? We still have the logs. Okay. Save open end. Can't compare that way in C. What the fuck? Oh, okay. So this must be like when I pressed the wrong numbers, I'm guessing. I don't know for sure. But I'm thinking if I put these numbers... No, I'm not sure. No, because this is where I was demonstrating zooming in, zooming out, and then... Yeah. Okay, so I don't know what the hell happened there. Yeah, I don't know what the hell happened. Oh, look at that. There's some numbers hiding up there. There's some numbers hiding up there. Okay, I see. Okay. I see. We had some numbers hiding up in the file. I see. Okay. So this does look kind of cool. Let's go use this one on something else. And if we can use it on one more thing and it gets something different than this and it still kind of looks cool, then we can make that a thing as well. Okay? And we'll call it accidental injection. I don't know. Something like that. I don't know what we'll call it, but whatever. Okay, you know what? That is interesting. So yeah, here, we'll go, we're gonna go export this one. I'll call it accidental injection.txt. And then we'll go file, we'll go open. Okay. And then we'll go back into kanji coder. We'll go into faux face here. And 629 is the next slot. So we're going to go find 629. Where is 6? Is it 629? No, 269. Oh my. 270 to 269 right there. Okay. So we're just going to make sure that these random numbers don't do anything super cool. And as long as they don't do anything super cool, we'll overwrite that, right? That actually does do, that actually is kind of cool, right? It's kind of cool. It's kind of cool, but it's also blurry as hell. I'm gonna overwrite that. Okay, so 269 here. We're gonna overwrite that. And I'm gonna call this one accidental injection, right? So the name of this filter will be we'll call this one accidental injection. So then 269. Oh my god! Doorbell. Hold on, let's check the doorbell. Okay, so we kind of like that. Let's go find chat really quick. Oh, okay, ban them. It's a bot. Okay. So we got this accidental code injection thing. And then we're gonna go find next, and it's gonna be T269. Okay, so then going back to where we were though, right? We had the original recipe that we wanted to use, and that's in recipe.txt, right? Recipe.txt is still here. We're gonna go back to main, we're gonna go to customize, and we're gonna go import again, and we'll do recipe.txt, right? And then we're gonna run this. And this one should get more of the swooshiness, yeah? Yeah, much more swooshy, yeah? Okay, so we're gonna go load the original photo that we used, right? And we're gonna make sure that whatever happens, that now when we use this, we should get this, right? Because we accidentally put some stops at the beginning and now we don't have them anymore, right? Yeah? Okay, cool. So we're gonna go into here, we're gonna go export this, and we're gonna go rewrite over the recipe.txt, replace it, then reload that, and then we're gonna delete all the way to here, so just we have just the numbers that kind of matter. And then we'll copy that. We'll go into PHOFace here. So 268 is the next available slot. Let's make sure that 268 doesn't look super cool. So 268 right here. We're gonna run it. So far, I'm not impressed. Yep, not really impressed. It would make a good... It could make a... 268 could make a good... Oh, what the hell did I press? That's not 268. 268 could make like a good face filter. But I don't know how I feel about it. I feel like we can make more varied effects by actually looking at things and doing stuff rather than getting emotionally attached to some random numbers that we generated just because it looks kind of cool, right? So one more time, let's look at 268. So this seems like some bullshit. Okay, so we kind of blur the image a little bit, and then we use some gradient ramps of some sort. What gradient ramps are those, though? Because I see these are just two whatevers. Okay, so what I'm going to do, here's my new numbers. I'm going to mess with that. I'm going to keep it by doing something with it as like a, that could be like a jumping off point. So I'm going to keep that on my clipboard for later. And then in PHOFace here, right, 268 here. I'm going to call this okay, this one here, I will just call this, so it's 268. Something like that. Okay, so now that I have this 268, I'm going to go up into the code here. Okay, so now what I want to do is, we have that stuff on my clipboard, right? So if I grab onto this, can we bounce back and forth between the new stuff and the, we can, okay, cool. So, these numbers were kind of interesting. So what I'm gonna do is, I'm gonna go here, I'm gonna hit reset, and then I'm gonna hit 0 and 0 and 0 and 0. So I'm gonna do a whole bunch of 0 do nothing filters. And the reason I'm gonna do that is so that if I look at the log for, this is the PHOSIMP log, I see this thing here and I see a whole bunch of zeros. So I got this clean slate, right? And we have these numbers, and this is kind of tedious, but we have these numbers that we thought, oh, you know what, that kind of does something interesting, right? So we're gonna go redo this by hand to get that beginning part, right? 262, 263, 264, and then 265. Okay, so these things don't do anything. They're just doing the inverses of each other, right? This is the inverse of the... These two are these two are complementary. Oh my god, fucking hell. These two are complementary. These two are complementary. Oh my fucking god. So that's why I put extra space at the top of the file. Now I understand. Okay, so 266 and 267 are also complements of each other. Yeah. And then, oh, actually, you know what? Instead of deleting those. Oh my god. Oh, we just lost it. We just fucking lost it. We just fucking nuked. Edit. Well, we just nuked it. We just fucking lost it. We had that cool thing, and we were like, "Oh, that's cool. We'll save it, right?" And that we fucking Control Z'd it to fucking hell. So we lost it. Okay. So that kind of sucks. So we know that, like, whatever. We'll make something else interesting, right? So 262 and 267, right? Oh wait, we still have this on the. Let's go back to main. Let's go back to main. It's still in the customization menu, so we can still save this. That was, we overwrote that though, right? We overwrote that. This is why you gotta be careful sometimes, right? Because, like, you do something stupid. 268. Okay, so 268, we haven't recompiled yet. And 268 was this thing, right? And these are a whole bunch of meaningless operations. And then it's the 276 and 277 that looks like it's doing something interesting. So we're gonna go into main. And that's 268. So 268, we're going to go customize it. We're going to go customize slot 268 here, right? So if we run this, right, that's the thing. 268 we already overwrote in the source code, right? It's already been nuked. But we're like, hey, maybe we could start off with this as like a base for something, right? So what we're going to do is we're going to go hit export. And we're actually going to save this shit rather than just put it in a random notepad file that hasn't been backed up, right? Okay. So now, what the fuck? What the fuck? Okay. Okay, what the fucking hell? Okay. Let's try to export that one more time. Okay, this is... Okay, recipe. Okay, recipe.txt, right? Save. Yes, I want to replace it. Okay, now we're going to reload it. I don't know what the fuck I just did there. I'm losing my goddamn mind. Okay, so these numbers here... We think they would be good to, like, start off. Oh, those aren't the correct goddamn numbers. Hold on. Okay, why? Why am I... IQ. I need more IQ points. That's what's going on here. Okay, so no, back, 268, run. Oh, okay, I see. Okay, so this is a good case for factory reset. Okay, this is not the fucking pattern, right? We're gonna go back. We have this thing called factory reset. Hit factory reset. Bam. Okay, now we'll run it. Okay, now we have the correct recipe, right? Now this is the correct recipe. How the fuck did... I don't know. I don't know anymore. Okay, we're gonna go back. We're gonna go Oh, we might have accidentally imported instead of exported. Okay, we're gonna go hit export. Okay, we're hitting export. That's why I was confused. Okay, because there was no overwriting because I import rather than export. Okay, so save, replace it, yes, reload. Okay, so now these numbers should make more sense. Yeah, these numbers make more sense. Okay, so now with these numbers, we're gonna look at them and we're gonna try to recreate this, right? So we already know that a lot of these are inverse of each other. 272, 273, 274, 275, 276, 277. Okay, so 274 might be the first one that is not gonna, yeah. 274, 275, right? 276, and 277. So basically we design filters so that when we use the filters in order, usually something interesting will happen. So I'm going to go 1,111 to just make this symmetrical. And then I'm going to go 278, kind of where we left off. And then I'm going to go 1,111 again. And then I'm going to go 279, kind of where we left off. Then I'm going to go 1,111. And then I'm going to go 280, where we left off, right? Then I'm going to go 1,111. And then I'm going to go 281, where we left off. Then I'm going to go 1,111. And then I'm going to go 282, where we left off. 1,111. Then I go 283, where we left off. 1,111. 284, where we left off. 1,111. 285, where we left off. 1,111. I would say that's bullshit. We just kind of 288, 1,111. I would say that that was not a really successful way to do things. 272, 274, 273. Blur it vertically. 274, 275, 276, 277, 137. Yeah, I'd say that we're not really that whatever we're doing here, the original image does not matter anymore, right? That we have nuked this to hell. Okay, do we just want to stop there? I mean, that's kind of interesting looking, right? But I feel like we used way too many steps. So we can look at our logs, right? And I don't know if we did these steps at the beginning, because I see like the resize viewport, but I see that this is where we zeroed things out. So I don't know why there's a resize viewport there, but I'm guessing these are all my steps. Okay, so what we're going to do here is we're going to go open up a new notepad here, and we're going to see if that's 66 steps. We got too many steps here. Oh, actually, no, we don't, because if we get rid of these, then we're at 62 steps. Okay, so we went a little bit crazy. I'm not sure how we feel about this, but I'm going to go Control A. Ooh, not Control A, Control Z. I got rid of Control A because sometimes I accidentally nuke entire super large files when my finger slips, and it's like I don't want that risk. Okay, so I'm gonna take these numbers here I want to mess with and make some interesting pattern later. So I'm gonna put them over here again to make something else interesting after I do this. Okay, so here's our recipe here. I'm gonna go save this, and then we're gonna go into here. We're gonna go import, and we're gonna hit recipe.txt here. We're gonna run that. We're gonna run that and see if it does the same thing, right? So we still have this open here, right? And we know that we're doing the exact same recipe on the exact same number, and we just want to see if we get the same thing, right? And I'm not sure how I feel about it. It's kind of fun how it's like just doing a whole bunch of crazy stuff. But yeah, I don't like this seam here, but that's why we blurred the hell out of it after that, right? Yeah. Okay, there's so much stuff going on that I doubt that if we load a different image, right? Were we here? Was this the step? 262, 263. No, that doesn't look right. Let's go import. We're gonna go import. We're gonna go find recipe.txt. We're gonna open that up. Oh, maybe that was. Okay. So we kind of know what the steps kind of looked like, so no, that doesn't look right, does it? Oh, no, that does look right. That does look right. Yeah, that looks right. Okay, so yeah, and then it kind of softened out to one thing, so we use like the 240 filter to try to bring stuff back, right? Uh-huh. Okay. Interesting. Okay, we had the seam, and then we kind of blurred the seam, and then we got this kind of flat thing, and then we did some other stuff to it, and then we called it a day, right? Okay. Let's go load something else. Let's go load this little dragon thing. And then do this slot here. Let's go run that. And then okay. So we can see that the output is kind of chaotic, and that kind of makes sense because we did like mm-hmm. Mm-hmm. And then we had the seam, so we were like blurring the seam. Okay, yeah. Okay, so this actually looks almost... No, it's not identical, right? You see that, like, this is different. It's definitely different, but it has a very similar look to it. That's kind of what I like, when it has, like, it's different, but it has a similar look, right? Okay, so I kind of like that. We're going to go hit export. And we're going to overwrite recipe.txt, right? Save that. Yes. Okay, so now we're going to go in here. We're going to reload it. So we see that it starts with, ooh, I don't know if it's going to start and end with 4, is it? No, oh, that says 37. Okay, so now we have these numbers, and we're going to go put them into the source code, and 267 is the next kind of slot. So 267 here, we just want to make sure before we overwrite it that 267 doesn't do anything like super cool. Okay, so I immediately am looking at this and I'm like, that's trash. We can overwrite that. So 267 over here, we're going to overwrite it, and okay. And then this is 267. So I'm going to call it Necromancer Chaos Modulation. The reason I'm going to call it Necromancer is because we kind of nuked the image, and then we brought it back where it looked like the image was like completely flat, and then we just brought back detail, right? So I'll call it Necromancer Chaos Modulation. Sure, why not? Okay, so now we're going to grab onto that, and we're going to make the display name here. So 267, right? 267 here. Oh, it just fits. It just fits, right? Yeah? Okay. And so this is 267. Okay, so while I was kind of doing that, I kind of like... We were kind of like onto something where we're like, oh, this actually might end up being cool, and then we kind of trashed it, and then we kind of recovered it, right? So let's not do that, right? Let's, 262 splits things apart, and then like we know that 288. Okay, so 262 splits things apart. 288, and then we're gonna go 263 to put it back together, right? Okay, that's looking cool. And then what we're gonna do is we're gonna go 377 to soften it up and put a gradient ramp on it. And then 240 to darken it a bit. And then we're gonna go 264, which probably splits it apart. Yes. And then 284 also is a filter, right? Yeah, 284 is another filter. Okay. And then I forget which thing we used in the log. Let's go find the log here. It was 263. Okay, so 263, we're going to put it back together with 264 then, right? I think. Nope. Um, 265 to try to reverse back to there. Okay. Then 264 maybe? 264 to put it back together? Nope. How about 444 again? 263. Okay. 444 again. 262 again. 444. 261. Nope. 263. There we go. Okay, it's back together. It took a while, and now it's very messed up. 377. 288 again. 137. Blur that vertically. Put a 4 on that. And I'm not sure how I feel about this. So 262, why couldn't we reverse 262? 263 would reverse it. 288. 263. I don't know. I don't know what happened there. Also, we've kind of lost all the kaleidoscopic detail we had, right? Yeah, I don't really like this. Yeah, I don't really like this, and I think we've done too many steps. Okay, so 262, 288, and then 263. I like that. Like, that's pretty cool, right? And then the idea was that we could do 264, and then maybe 280, and then 265 and put it back together, right? So we're going to do like 264, split it apart, 280, some other weird filter, right? And then 265, put it back together, right? Okay. Then we put a gradient ramp on top of that to increase the contrast. Then we could do 1111 to tile it a little bit more. Then we could do 11, and then we could blur across the grain. Then we could do some random auto tiling filter. And then we could do a blur filter. And then another random blur filter. And another random blur filter. Another random blur filter. Then we could do 1010 Oh, that's not 1010. And then that actually looks kind of cool right there. We could try to sharpen it up, but I don't know what we would sharpen it up with. I mean, we could do... we keep on using 300 to sharpen things up. And it does actually look good that way, yeah. Okay, so now if we move it around with 33... let's kind of center that. Sure. Okay. I'm not totally satisfied, but it looks different. And it kind of, we did mess around with like splitting the image and merging it back together because that's kind of what I wanted to experiment with. We got something kind of cool. Maybe not the best, but whatever. Okay. So we're going to go look at our logs and make sure that our logs aren't too many steps here, right? So can't compare like that and see this thing right here. Okay. So we're going to grab this, we're going to copy it. And we're going to go into recipe.txt right here. We're going to paste these new things from the logs. We're going to save it. And then we're going to go open up this. We're going to go into main, customize. We're going to overwrite the slot. We're going to go import. We're going to go find that recipe. Recipe.txt. Open that up. And we're going to go load the default image here, because we want to make sure that when we run this, that we get the exact same thing, right? So I like the whole splitting it up and putting it back together. Okay, yeah, that's pretty cool, right? I like that. Okay, so now the thing is that we want to make sure that when we do use a different image, that we don't get something that just looks like crap. It could look drastically different, but as long as it has like the same feel and it looks cool, then I'm okay with it, right? So much different, but it has that same kind of feel to it, so I'm okay with that. Okay, let's use one more image. All right, so that's pretty cool. I kind of like that. All right, so it's good enough for me. Okay, so now what we're going to do is we're going to go export. We're going to export what we just did. And we're going to call it recipe.txt right here. Save it. Yes. Okay, then over here, we're going to reload this. And now we have much more nice formatting that is going to go into our source code. Okay. So in the PHOSIMP source code, we're going to find slot 266 here. Yeah, 266 is the next slot. And we do want to make sure that 266 doesn't actually like look really cool, right? So 266, random numbers, and they look like shit. Okay, just making sure. Okay, so now what we're going to do is in slot 266 right here, we're going to paste this code right here. We're going to take this stuff here. Okay. And then we're going to clean this up. And also, we haven't described the last filter of this video yet. So we still need to explain ourselves for everything before we get out of here, right? Because this video is trying to like explain all the filters, and I was explaining stuff, and then I was making designs, right? But the idea is that I know not many people are going to watch these videos, so I thought that I would just ramble. And then, yeah. Okay, so 266 is right there. And R266. Split and merge experiments. Okay. And then we're going to go up. And, we want to find this. Okay, 266. Okay. So let's go back here for a second. So we're explaining filters 31 to 40, but we never explained 40, right? And 40 is doing something crazy, right? Now, chances are the image is blown out, but there's something kind of hiding in the dark. Oh boy. Okay, so 40, I have like a filter that could normalize things when things go out of bounds, and I see that like these pixels look very blown out. I'm wondering how well my new HDR normalization filter will work. That's 1281. Let's try 1281 really quick. I wonder what 1281 will do. Oh my god, that actually is pretty damn cool. That's weird how it's like there's this like weird kind of like intestines glowing on it. Now, if we use 361 to get rid of the transparency, do we lose those cool intestines? Oh, that was not. 264? No, what was the one? Oh boy, I'm losing it. 361? No, 364? Where was it? I don't remember what filter it is. There is a filter for like zeroing out, but I'm forgetting what it is. 40. Okay, so we know that 40 and then normalizing it with 1281 can get some cool stuff. But I can't figure out, the image is glowing and I'm forgetting what number 345? Oh, 346. So the 346? Yeah, it's 346 that gets rid of the... Okay, it was 346. And... but it's kind of too late because we already kind of... Okay, let's use 40 again. It was 346, now we remember. And then we use 1281 to normalize it. 1281 for... Okay. Sure, I'm going to keep this. I know it's not the most interesting design and it's black and white, but that 1281 was kind of a reminder to myself that, oh, normalization, and then we kind of screwed up and lost ourselves, and now we made this, right? I'm okay with that. So sometimes we just have these little happy accidents, and we're like, you know what? It's not randomly generated. There was a feedback cycle of a human being in this process. I do want to mess with 40 a little bit more. Like 40 we need to explain. I don't quite know what 40 does, but I'm trying to make 40 do some interesting things. Okay. So in our recipe.txt, we're going to paste that stuff, and we're going to get rid of all this bullshit right here, and we're going to save that. We're going to go over here. We're going to go to main. We're going to go to customize. We're just going to keep on overriding the same slot so we don't lose track. Recipe.txt, open it up. We're going to go back up, and we're going to go load the default image of PHOSIMP into here. So that way when we use this customization, we should see the same process, right? Okay, so are we seeing the same process? I'm feeling like we're not. Well, I mean, we'll see, right? Because we'll get the same exact thing, right? If we didn't miss it, if we didn't miss anything, right? Okay, yeah, so it's the same thing. Okay, so my question is, oh god, that's not what I meant to do. And that was kind of glitchy because it showed the back menu, which we don't want. Oh, whatever. Okay. So the question is like, if we use a different image, do we get the exact same pattern? So let's see. Okay, so if we run this now, I feel like a lot of this, I feel like it's going to get a pattern that looks almost identical. I don't know, though. Oh, that looks a little bit more smooth than the other thing. That feels like it has a little bit more color than the other thing. Okay, So the pattern is a little bit different in there, right? Like I can tell there's a little bit more like red in this. And then we can see here there's a little bit more horizontal striping here than over here, right? But it's very similar, right? I'm okay with that. Right, and it's not super psychedelic and shiny like the other things, but I like the fact that it's different, right? The fact that you can make a whole bunch of different things. Like if you make a whole bunch of things that look really cool, but they all look the same, that's not going to add much value to the software. Okay, so how do we feel about this? Ooh, that's very similar. So this is kind of lacking distinction, right? If there were two filters that made things that look this similar, it would not be acceptable. But when it comes to different inputs, getting very similar results, I'm okay with that. It would be very interesting to see what happens if you put an animated image in this, right? Because the results are so similar, the animation that you could create would be like very interesting. The fact that like the subtleness of the animation can be interesting, right? Like having crazy things happen over time when you put the recipe onto a video. Having crazy transformations happen is interesting, but also having subtle differences happen over time, I think, is also interesting, right? There's a lot of things we can experiment with. Let's go use one more thing. So this was the other one we've been using a lot. Okay. And we kind of have an idea of kind of what we're going to see. And I do like the fact that my normalization filter is actually doing something of use. Okay. Once again, it is different, but it is very similar. So we see here there's a little bit more black here in this horizontal stripe, and there's a little bit more gray here. And then this pattern is slightly different, but yeah, overall it's it's pretty much the same compositionally, right? There's a bright stripe in the middle, dark stripes on the top and bottom, but the exact texture is slightly different, right? Okay, so we're gonna go hit export on this, and we're gonna go call it recipe.txt. We're gonna save it. Yes, I do want to replace it, and then reload it. Yes. And then in the source code, if we can find the source code, because we're losing our mind here, we want to make sure that whatever we're overwriting doesn't actually look interesting. Oh my god. Okay, copy that to the clipboard, and then in PHOFace here, it looks like 265 is the next available slot. So the question is 265 actually interesting, right? So 265 is right here. Okay, so 265 was just a whole bunch of random numbers put in as a placeholder, and it looks like complete shit. Okay, so I'm confident that we can just nuke 265 and put this in, right? And even though this may not be like, ooh, wow, amazing, right? It's different and it's interesting, much more interesting than those random numbers, right? So the actually having human intervention and input is important, right? I know that we're in this like age of AI generated everything, but like having a human in the loop is very important, right? Like it may look like, oh, I'm just pressing stuff. Oh, I'm just pressing random numbers. I'm not. It might look that way, but there's a feedback cycle happening, right? And it's very obvious that there's a feedback cycle when you try to like actually press random things and actually just inject random numbers, and you're like, that looks like shit, right? Okay. So 40, we're still not quite sure what it does, right? But we know that as we've been working on filters, that we were working on normalization filters, and we know that when things go out of bounds, that we can use this 1281 to, oh my god. Let's reset. Let's go 0, 0, 0, 0, so you can see where it is in the logs. let's use 40, which we still haven't explained, and then let's use 1281 to renormalize the color. Okay. And then it's not actually, it doesn't actually have the weird pipe thing that we had last time. I wonder what that is about. I don't know. I don't know what we did different that time. I'm going to use filter 4 on this. And then I'm going to use, oh, that's kind of interesting. I'm going to use 40 again. Okay, that blows things out. Everything's blown out. But now this could be more interesting if we use 1281 to renormalize, right? So we're going to compress the color range back into the visible spectrum so that we get less blowout from these pixels, right? It's going to scan the entire image and compress. 1281. So that actually is kind of interesting, right? That is actually making some interesting things happen. Okay, we're going to do 1111 and 16. And then we're going to blur that horizontally. We're going to use 40 on top of that, again. And then we're going to go 137 to interlace the pixels. We're going to do 377 to blur it up a little bit. And then we're going to do that normalization step again. We're going to do 1281 and see if we get more interesting detail. Okay, so this time 1281 didn't really do anything. Could have been, did we do like a gradient ramp? We may have done some things that kind of wrecked the, got rid of the variance, whatever. Okay, so let's do 40 again. I want to do 40. I want to kind of keep on messing with 40, blowing out the pixels, right? Blowing out the pixels, and then bringing them back with 1281, right? Right, that's kind of fun, right? That is kind of, I kind of like doing that. So I'm gonna use I'm gonna use 1010. And that's kind of interesting. I'll blur it vertically. I'm going to use an auto-tiling filter of some sort. And then I'm going to go through here and... Okay, I really don't like the fact that we added that texture. Because that texture is... Yeah, these textures here, bad news. Because the reason those are bad news is because... that was bad. I think I'm going to remove those auto tile textures that kind of put stuff on the... we need to do an audit of some of those auto tile textures because some of them I think we don't want in here, right? Like if they make it so that the image is, we want the image input to matter, and some of those auto tiling filters are like compositing, not this one. Some of those, they were debug auto tile filters that just like, yeah, yeah, this one we really want to, this one, these ones we don't want these in here. In fact, I'm gonna, these ones that say touch ring bug, 161 to those ones can stay because these aren't embedding a pattern, right? This is like a hard-coded pattern. 161 to 172. Okay. So in it's also 1161. Yeah. Touch ring bug. Okay. So right here, Control Shift F2, Control 0. 1161 to 1172. We do not want these in our little aliases. And somewhere in our memory we have like these aliases. We gotta look at the index. So in the index, we have some type of filter aliases of different types. So alias A is autotile filters. Alias B is those blur filters. Calling it alias this and alias that is... Okay, yeah, I like that. Okay, so alias A, and then it was like the 1161s. It's not in here. 117, 116. Am I losing my goddamn mind? I thought it was 1161. Oh, there's not... Okay, hold on. 1161. Oh, 1161 is not actually in here. Okay, I did actually make that decision already. Yeah, certain things are cut out of here if I thought it... It's not in here, never mind. It's not in these aliases, because I was seeking around after using the aliases, and that's what kind of screwed that up. Okay, never mind. Okay, so I really like the 40. I really like blowing it out with 40, and then doing 1290, right? I thought that was pretty cool. What the fucking hell? Oh, 1290 is too high. We just crashed the program. 1290 doesn't exist yet. I was supposed to do 1281, so now we gotta like rebuild. Okay. So we still haven't explained what filter 40 does. So let's go PHOSIMP 040. Let's go find filter 40, figure out what it does. Halftone bounded box. Okay. 40, 41, 42, and 43 are all variations of each other. We got an operation code, a max radius, accumulator collapse, question mark. Accumulator collapse looks like it's some type of normalization stuff. Ring box. So this looks like... So first of all, we can get some clues as to what this does by doing 40, 41, 42, and 43, right? Because they're all somehow related. So I'm going to do 40. I'm going to look at it. Okay, I'm going to do 41. I'm going to look at that. I'm going to do 42. Look at that. And then I'm going to do 43 and look at that. Okay. So, I think what it's doing is it's pasting a whole bunch of boxes of possibly average values. Operation value, operation code. Okay. Here's our operation code. Okay, first of all, let's look at the operation code, right? So operation code is going into this thing that has an operation code. Okay. And then do we do anything with that operation code later? Apparently not directly. So that must mean it's the object itself. The object itself is being fed into a struct somewhere, right? And we can see this like ring box thing is we have a whole bunch of that's some insane code right there. We have an array of pointers, and we're taking pointers to each one of these structs, which is like, why? Like, why the fuck am I doing that? That's fucking stupid. Not only is it fucking stupid to write something like that, Like, I have no fucking... Why would I do that, right? It's fucking stupid because also, like, if I want to take that and I want to convert that to, I don't know, JavaScript code, right? Because there's a JavaScript version of this. Whatever I just did there with passing around fucking references to structs, like, good luck doing that in JavaScript code, right? So the question here is, like, is that even correctly translated, right? So we see this is an array, and we have these individual things, right? And okay, so we're saying this is allocated. Basically, this is allocated on the stack, and we want to pass in the actual references. Okay, I guess that's not too stupid. That's not too stupid. Okay, so we have a whole bunch of pointers. We have these 4 things allocated on the stack, but if we want to pass things around to functions that are helper functions, we don't want to pass by value. We want to pass by pointer. So this kind of makes sense. Okay, and we put it in an array so that we can do the operation for red, green, and blue. And these operations are all the same thing, right? Ring box operation code for ring box operation. So the same operation is being applied to both the red channel, the green channel, the blue channel, and the alpha channel. That's what that looks like. CI4, that means it's an index that goes from 0 to 3 inclusive for 4 different indexes. C index, I don't know what the C is, but probably common opcode index. I see this as CR. This little thing has a $sign on it, so we can kind of investigate where that goes. Channel index of which there are 4. CI4 stands for channel index of which there are 4, right? So what we could do here is we can make a little comment here. Just set at CI4 channel index 4 total, right? We had an idea that that's kind of what that variable meant, something like that, but we weren't 100% on it, right? Okay, so now this is the C code. Where is the JavaScript code? Here's the JavaScript code. We're going to make that note as well. Okay, so now we're going to go back to the C code and be like, okay, so we got this like opcode array for all the different color channels, and we're putting it in an array that's temporary, so at some point we're going to want to loop through it. And we have ringbox RGBA. Here's ringbox RGBA doing something with it. Are we ever using that fucking array, right? Okay, it's right down here. RGBA ringbox loop. Okay, so we are doing something with it. All center points same. Okay. Filter 40 loop. Okay, let's go look at filter 40 loop and see if there's any explanation here. I really do need to make explanation. Outermost workhouse, probably make at least filter 40 unique logic. Logic unique to filter 40, blah, blah, blah. Actual boilerplate code. Vars unique to filter 40. Okay, so I gotta say, holy crap, I need to, like, I made a whole bunch of documentation and it's like, filter 40, still don't quite know. I was high on caffeine when I wrote this. Okay, so ringbox, we might want to know what it represents. I mean, from the name ringbox, I have a good fucking idea, but ringbox, that is a macro for this struct. Let's put a breakpoint here so we can come back to this point. Okay. So right here, ringbox, pixel center X, pixel center Y, radius of the box or ring. Okay, so we're making either like a filled box or a ring. And we see that we have some options. Ring box 2 values. Color channel index to effect. The opcode is add, sub, multiplier, divide. Okay, and then is there also a radius? There is a radius. Okay, so I'm fairly certain what we're doing is we're stamping a whole bunch of boxes or rings. So basically, is it filled or is it not filled? and of a different radius. How do we control the radius? I don't know. Now, when we're stamping them, we can either add, subtract, multiply, or divide when we're doing our stamping. So it's like an opcode for how we blend with the image we're stamping on top of. And luminosity to add, sub. Okay, so these are kind of these options, and I guarantee these options are somehow getting into... let's open up a... Let's take this, like, scratch recipe.whatever. And did we put this recipe in... before we get distracted, is this recipe here? It looks like we did this and then we got distracted. Okay. That's not the thing I wanted to... Did I really want to bring this over? I don't think I wanted to fucking bring this over. Well, now it's over here. Okay. So, for 265 here, we'll just call it, okay, we'll call this I forget distracted by ring boxes. I forget distracted by ring boxes. That's what we'll call this one. Okay, so 265, I know we're like all over the place. So let's go back over here. I forgore ring box of sure, ring box of amnesia distract, right? It is actually using filter 40, right? Because the reason we got distracted was because it was using filter 40 and we were trying to figure out what filter 40 does, right? Ring box of amnesia distract. Okay, so if we grab onto this, right? Let's recompile this, right? So not this one, but this one right here. 265. Let's just do a little audit, right? We've kind of made some things in this video, and we do want to make sure that we haven't like done anything disastrously wrong, right? We want it to still compile, and we want these new recipes from 265 forward to make sure that they all look cool, right? So we made a syntax error while we were editing the code. So let's go fix that really quick. I'm sure it's just the lax comma. No? Is it a lax comma on somewhere else? Okay, what line is it on? Error. Oh, 0613. Right here. Okay, so we went pretty far. So testing out 265 to maybe 270, right? Or maybe a little bit further, whatever. Okay, so let's get this running. And let's just test things out and just make sure that we don't see any bullshit, right? Like, oh my god, okay, we're just bullshitting today. Okay, so we kind of got on a point where we just started kind of like making modifications and not actually recompiling because it was taking up time. And the thing is that if we don't test things, we probably made some mistakes, right? So, oh, Jesus Christ. Okay. We made a lot of mistakes. Okay, so this is, yeah, this is obviously fucked, right? Okay, So we have like a section for documentation. We should probably start writing the documentation. Like as we're going around and like making these videos, we should also be writing the documentation strings, which we have not been doing. So we need to do that as well. We need to make a note for that, that we need to make the documentation strings. So I'm going to make a note here that make documentation strings. Okay, and we'll do that before this video ends. I know it's like 1 hour and 50 minutes. Okay, so let's put this on this side of the screen. We're gonna go load this face because we've been making all the images kind of with this first, and then we've been kind of importing them in here. So we should start with this, right? Now we want to look at the source code and know kind of like where we left off. So 265. Okay, so we're gonna use 265 first. I forgot distracted by ring boxes. Okay, I remember that. Okay, and it's not a bad design for I forgot or calling it amnesia because it's all grayed out and it does actually feel like if any filter was to be called amnesia, I think that's a good one. Okay, so on to 266. This is called split and merge experiments. I kind of remember doing this. Yep. Okay, that is looking good. All right. So now we're going to go on to 267. Okay, so 267 here, right? We're going to use this, and we're just going to see what happens. Okay, I remember this one where we kind of like alternated between like 111 and then the 285 and 83 and 81. And we thought we were going to get something interesting eventually, but it eventually started to flatten out. And then we're like, we need to get the detail back. And then we tried some things, and then it just became completely chaotic. And then we got something that I wasn't too happy with, but I know that like other people who have never used PHOSIMP before will be like, oh my God, that's awesome, right? So we kept it. Okay, so then Necromancer Chaos Modulation, right? Because we brought it back from the void. Okay, so then there's 268 here. So 268, okay. 268, let's take a look at 268. And yeah, injection fix accident. Okay, yeah, we accidentally injected a hard-coded pattern into it. I'm not a fan of that. Okay, so 269. Okay, 269. Okay, 269 was pretty cool. Yeah, 269 is fine. 270. Oh yeah, this is the thing that I'm like, oh, it looks really cool for this default photo, but it doesn't look cool for all the other default photos. I remember this one. Okay, so 271. 271 right here. And then I think 272, and then I'm good, right? If we do 272 here, like I'm satisfied that everything down there has been hand designed, and that, yeah, I'm okay with it. All right, yeah, that's fine. Okay, so we're still trying to figure out what this is all about, right? So luckily for us, because we have a JavaScript version and a C version of this, we can basically cross-reference these and it'll be fine. So for example, if we go look for ringbox here, if we go look for this ringbox type in the JavaScript version, we're also going to find it, and it's going to have the exact same explanations, but you see the syntax is slightly different, but you see that it's all there, right? Pixel center X and Y, pixel center X and Y, pixel center X and Y, right? Radius X, radius Y, radius X, radius Y, right? It's all there. Though I'm not sure why I didn't do this right here, like 1, 2, 3, 4, and then like over here, like, you know, I don't know, but I'm gonna do it now. 1, 2, 3, 4. Okay. Okay. So, with this code, we want to know, like, these are obviously options that we are messing with. So if we go look for the RB2 value here, okay, so we see that, okay, this is kind of being helper ring box. Ooh, helper ring box. Okay, helper ring box, is that being used in our function? Is this the function that we're looking at, right? I think it might be. Yes, it is. Okay, so we have the operation code, we have the maximum radius, we have the accumulator collapse. The operation code, is this a... Okay, then we have like a max radius. Okay, the operation code is like that, add, subtract, multiply, divide. Luminosity to add, sub, multiply, divide. This is probably something that keeps on changing, I'm guessing. Like, it's like an argument. Yeah, that makes sense, because there's a radius argument and blah, 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 and operation code, right? So some of these arguments are being inputs to the function. Okay, so now that we kind of know this, we see these arguments right here to this function here. That first argument is the operation code, or not? Operation code is always 0, which would be add. No, add. Oh, we're doing add, and then subtract, and then add, and then add, and then... And then 44 is just like, what the fuck? 44 is different code. Oh, hey, look at this. These little explanations here, halftone bounding boxes and out of bounds rings. Okay, so we probably have some explanation here, right? We found the explanation, but it's not in the body of the function, which is the thing that fucking confused me. Okay, so let's go find next. Oh, yeah. So there looks like we might have found some documentation. Okay, so we have some documentation. I'm going to go pause this recording really quick. I'm going to go take a break. I'll be right back. All right, so halftone bound box ranges and out of bounds rings. Render boxes when in range. Render boxes when in range. Out of bounds ring. Render rings when out of bounds. Okay, so there's something where, like, depending on what we're looking at, we render boxes or rings. Oh, so I think what that means is, like, if the color value is outside of the visible spectrum, we're going to render rings, and then if we're in range, we render boxes. Try and design a filter that will rein back in out of bounds, over white, and under black RGBA values. 1, normal render RGBA. Normal RGBA rendered as boxes. Okay, so we see normal RGBA pixels, we draw boxes. And these boxes have like a radius, right? So we're stamping a whole bunch of boxes on top of the image. Out of bounds RGBA rendered as 1 pixel thick rings. Okay, so if we go out of bounds, like if we detect pixels that are out of bounds, we stamp a ring, like a wireframe ring, on top of it. Okay. Boxes and rings never go outside of the selected area. The selection area. Oh, boxes and rings never go outside the selection area. So that just means that if we use the tile brush, those rings will not go out of the selection area of the tile brush. Okay. Maximum box size is 64 by 64, so that I can observe the boxes leaking outside of the 32 by 32 tile size when the tile size selector is 1 single tile, and every single tile is 32 by 32. So it's talking about, like, the tile brush here. When we're testing this out, right, we can make this a 32 by 32 area, and the largest box that we can draw with filter 40 has a radius of 64. And so if the filter is working correctly, we won't see anything leak out of this, even though we're drawing a 64 by 64 box inside of a 32 by 32 box, right? We're drawing a bigger box inside of a smaller box, and the bigger box is not leaking outside of the smaller box, right? Which is crazy, but it's because we are modulating our code, right? We're wrapping things around. Okay, I get that. Okay. So halftone filter that converts each pixel into 4 RGBA boxes depending on the intensity of the pixel and renders that box of color with the center point of the box of that pixel. Okay, yeah, I get that. Okay, so if the pixel is lower than -1.0, we render as a ring instead of a box. If the pixel is greater than 1.0, we render as a ring instead of a box. So for out of the visible spectrum, we're rendering as a ring instead of a box. Out of bounds value are subtracted instead of added. Okay. So we're trying to bring things back. Okay. So -1.0 ends up being negative minus -1 equals 1.0. So 1.0 ends up being negative. Okay, so we're just flipping things, kind of rendered as a small pixel thick rings. So it looks like we're kind of trying to, like, when we find values that are out of bounds, we're trying to like invert those out of bounds values before we kind of mix them into the composited image so that the colors will naturally gravitate back towards being in bounds of the visible spectrum. That's kind of what this is saying. Rendered as small 1 pixel thick things. The ring increases by diameter for every multiple of 1 the pixel is out of bounds by. Okay. Okay. So I kind of get what's going on there. Okay. So that's a good little explanation. And then does this bring me to a documentation section? Okay. So once again, what are these fucking numbers here, though, right? So we want to explain those numbers, and we want to centralize those numbers somewhere. So the first place we were looking for an explanation of what this does is we were looking in, yeah, so we have these explanations, but they're not inside the function. They're on top of the function because the function is kind of a wrapper. Okay. All right. So what I think I need to make this code clear is that this helper function, which is for 40, 41, 42, and 43, that's kind of the way that's notated, is that that this function is used specifically to create, this function here is used to create filter 40, 41, 42, and 43. We just call this function with different combinations of arguments to make these different filters. So we see these last three arguments for 40, and it says 40, 41, 42, 43, right? So 40, we see 3 arguments. 41, we see 3 arguments. 42, we see 3 arguments. And then 43, we see 3 arguments, right? So we see kind of how that's working. So right here, I may want to explain that, right? I may want to explain why the things are the way they are. And my convention for kind of explaining code, like making an explanation of the code, is I make this section called ATF for about this function. And I see that we're kind of indented kind of really far, because I guess that's how I decided to format this whenever I formatted this. I'm not sure I'm a fan of that, but we'll try to stick to the same formatting convention. And we'll take this, and we'll say, common function used to create filters 40, 40, 041, 042, 043. Since around the Okay. So, so it is, the operation code is 1, we have 1, 1, and then we have a 0. 41, 42, 43, and 44. Okay, so 1, 1, 0, and then we have like a 0, a 3, and a 1. I cannot type. A 0, a 3, and a 1. A 0, a 9, and a 1. And then this last one is... what the fuck? Oh, that's too far, right? 40, 41, 42, 43. This is 44. So I have my shit messed up. So this is not the thing. We're missing something right here. So 0, 40. Okay, so 43, 091, 031, 110, and then 070. Okay. So these numbers do not seem to have any visible pattern to them, so I'm pretty sure what happened was it was trial by error, right? It's like, here's these settings, let's mix and match these settings and see what things look interesting, and those will be our variations. That's probably how that went down. Okay, so we have these things here. We know that that the first thing is OP4, opcode 4, max radius, and then accumulator collapse, right? So the first two are not collapsing with the accumulator, which is like a normalization step, which makes sense because we do 40 and then we use that filter 1000, what the fuck was it? 1281 is a normalization step that would be similar to what this accumulator option is doing here for filters 42 and 43. So that makes sense that filter 40 ends up blowing stuff out because it has no accumulator normalization. And then we use 1281 to normalize it. Okay, that makes sense. At OP4, op code, and the opcode, and then we have MR, max radius in pixels, and then we have AC, so the reason I'm doing this here is so that very quickly we can look at filter 40, filter 41, right? We can see that if we have room for this, I don't know if we'll have room for this, but oh, we kind of... that is some tight quarters there. But that kind of explains it a little bit better, because now we know that we have two different opcodes, and I believe one of these is subtraction and one of these is addition. There's other opcodes, but we're only using 0 and 1, so we only have to denote those ones, right? Chances are the other opcodes just look so completely horrible that we did not make it into a preset in PHOSIMP. Okay, max radius, we don't got to explain that. Accumulator collapse, we already explained that. Okay, so the opcodes here, we have to go find those, right? So first thing we might want to do is, we see this right here. Why don't we go, say, OP4 operation code table. Okay, so I think that we should, as we're kind of working on this, we should maintain the comments a little bit and say, hey, where the fuck is this, right? So this commentary here. Filter number of whatever. Okay, we're gonna paste this commentary into both the C version and the JavaScript version. And so now we have a better idea of what it does. Let's make a better description. Filter stamps squares on top of pixels that are in that have okay, so something like that. Okay, so that helps me kind of understand what's going on. Okay, so filter 40 is just stamping a whole bunch of squares when it sees color channels that are in bounds, but we're stamping a whole bunch of squares and we're adding those squares up or subtracting those squares out, which will cause things to go out of bounds. So the next time you run the filter, the next iteration of that filter will usually get totally different results because you start with the image where all the pixels are in bounds, right? If you load an image from the file system, all those pixels are going to be in bounds because it's not a high dynamic range image, right? You load it from a PNG file. There's 8 bits per color channel. Everything is going to be within the visible spectrum, -1 to +1 when you load the image in. When you use the filter the first time, filters 40 and 41, which do not have the accumulator collapse option, stacking a whole bunch of squares on top of each other, offsetted at different pixel amounts, and like adding them all up or subtracting them all down, it's going to lead to going outside of that -1 to +1 range. And now the next time you use the filter, you're going to get a whole bunch of rings instead of squares because we're going to draw rings anytime the pixels are going out of the visible spectrum outside of the -1 to +1 range. Okay, so that makes sense to me. Like, I actually understand what that filter does now. And with that said, I also realize that if we want interesting effects from filter 40 in the normalization step, that somewhere in this video we like use this filter, and for some reason it didn't get the interesting weird pipe effect that we had the last time, and I realized why. It's because the first time we use filter 40, it's going to stamp nothing but boxes, because all the pixels right now when we loaded the image in, right, because we just loaded this image in, all these pixels are within bounds. They're within the visible spectrum. This is either going to stamp a square of a certain radius over a pixel, or it's going to stamp a wireframe square ring over a pixel. It's going to do one or the other, and it's going to do it per color channel. And it's going to do filled squares when the pixel is within the visible spectrum. It's going to do wireframes when the pixel is outside the visible spectrum. Because this image was just loaded, everything is in the visible spectrum. So if we use this right now, it's only stamping squares. But now that we've stamped a whole bunch of squares, boom, 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 and overlaid a whole bunch of squares, and it looks like we added them together, we're way out of bounds, right? Now we have a whole bunch of pixels that are outside of the visible spectrum. In fact, all of these pixels might be out of the visible spectrum now. Well, that means that the next time we use 40, instead of stamping a whole bunch of squares, it's going to stamp a whole bunch of rings. So the next invocation of this filter is going to have a totally different effect, right? Now, this may have brought things back in. So this might mean that maybe, just maybe, using 40 a third time, some places get squares, some places get rings. So 3 times in a row might be a charm. Interesting, we got the original image back somehow. Not completely back, but we got that chaos, and then now we have to see a face again. That's interesting to me. Now, we know we did not do the dynamic range collapse. So we have 1281, which is a tone mapping filter. I think that we're going to, that with all this blown out detail, if we use 1281, we're going to get some of that detail back. And in fact, that's kind of interesting. That is actually quite interesting. So I'm going to put a gradient ramp on that to increase that kind of contrast. And then I'm going to do, I don't know, 16 and 11. And then I'm going to do 40 again. I'm going to, because I do still want to experiment with 40. We know that using 40 twice or 43 times is a charm, right? 43 times is a charm, right? So if we use it the third time, we kind of get back whatever the original thing is. That looks like shit. We're going to use 1281 for the tone mapping, right? Okay, that's still kind of, that is kind of cool, right? It's very soft and it's very soft and subtle. But you know what? I think we should just stop it there, right? I know it's not super psychedelic and glowy, but it looks different from what we've made before, right? And I used it with the understanding of what filter 40 does now. So, and also the animation of those steps is actually kind of interesting. So we're going to go find the logs for PHOSIMP, which is the program to the left. And did we really use, yeah, we used 40 3 times in a row. So we did 40, 40, 40, 1281 normalize, gradient ramp, some kaleidoscopic action, and then we did 40, 40, 40, and then we normalized. Is that how we want to take it? Yeah, I think that's how we want to take it. Just a simple little concise little recipe that makes a kaleidoscope. Okay, so we're going to take that and we're going to copy it. And we're going to go find recipe.txt here. We're going to go paste that, and we're going to delete that. We're going to go save that, and then we're going to go into here, and we're going to go hit customize. We're going to just use a random slot. We're going to go import, and we're going to say recipe.txt, and then we are going to run this. Oh, hey, we still have the, okay, cool. So that should match this exactly after we run this, right? And if it doesn't, then we have a problem. And I think we have a problem. Okay, so what did we miss? Okay, so we're going to go back to the logs, right? Back to the logs. I'm actually a little bit confused because we definitely didn't do this. We definitely did not do 40, 40, 40, 40. We definitely did not do that. Oh, did we accidentally like click? Because that one square, right? We had that square in there. I bet we accidentally clicked And so this is actually what it is, because those squares we saw, that I was like, oh, those are some interesting squares. I think that was from accidentally clicking. See this little tile brush? I think that might have been from accidentally clicking with the tile brush, right? And so we accidentally tainted our thing here. Okay, so it wasn't that hard what we did though, right? So we're gonna hit 0, 0, 0, and 0 so that we can see in the logs where we're kind of starting out fresh. And we know that we did 40, and the 40 the first time. Okay, let's reset that. Okay, 0, 0, 0, 0, 0. Okay, so 40 the first time is gonna paste nothing but squares because every single pixel was in bounds. Now everything is completely blown out because we composited a whole bunch of squares on top of each other, and we just added, and just stacked a whole bunch of overlaying squares. So now the next time we use 40, we're going to stamp rings, because rings get stamped when the pixels end up blown out of bounds, outside of the -1 to +1 range. We can see that a whole bunch of these pixels are greater than 1, right? Because that's why they're blown out and everything looks whiter than it should be, right? So if we use 40 again, it's going to stamp rings, right? And that's kind of why we can see a much more kind of like filamented texture here, right? So now if we use 40, we're expecting that the rings that we are stamping were designed to try to pull the colors back in. So now if we do 40 again, we're expecting that we're going to have a mix of rings and squares. Is that what actually happens? I don't actually know. But the interesting thing is now we see the image again, which I think is really cool, right? So now we're going to use 12. Oh my god. I wanted to use 1281 to normalize it. Okay, let's just use 18 because my finger slipped. Okay. Then let's use 1281 like I planned to normalize this, right? The colors are still blown out, and the blur that we just did shouldn't try to renormalize the color, so we should still get something kind of interesting. Okay, that is still kind of interesting, right? I kind of like that. Now the thing is that we're right now designing something for the bottom, and so it needs to be kaleidoscopic. So even though that's cool, we need to still kaleidoscope things. So we're going to do 40 on top of that. And then do we want to, I'm going to blur that vertically. And then we know that 41, we don't know exactly what the difference is, but we know 41 also does not do a normalization step, so let's do 41 as well. Okay, so now everything is very chaotic, and you can tell, I can tell by looking at this that we have a lot of out-of-bounds pixels. So this is a great opportunity to do 1281 and try to renormalize the color, like tone map it. Okay, yeah, tone mapped. So now what I want to do is, I don't know what I want to do. Let's do, let's do 111. I actually have to look this up in the source code because I'm about to reference. I'm going to go into PHOSIMP. Where is PHOSIMP right here? Oh, I have two monitors open. Okay, I'm going to move this over here for a second. Okay, so PHOSIMP 1111. I've been using this a lot to like kaleidoscope things, and I know that these were arranged to be, okay, is this a set of 10? This looks like way too many. It should be in a set of 10. Why did I do this? 40 outer filters, tt.au.char, yeah. And that's debug. Okay, so like every set of 10, so 111 here, and then, oh, and then it's going to be 1121. Okay. I'm going to do 1131. Come on in, 1131. And then I'm going to do 1132. And then I'm going to do 1134. And then I'm going to blur that vertically. How's it going?
Yes.
Going all right?
Yeah.
And then I'm going to put this on top of it. And then I'm going to put 41 on top of that. And then we're going to try to tone map it again with 1281, I think. 1281. Okay. So I got to say that it's not it's not as interesting as I thought it would be because the tone mapping, there's a lot of variation. Trying to bring everything in bounds when there's a lot of dynamic range, it crunches things a little bit. Okay, that actually looks kind of cool, right? This kind of looks cool, so I think we'll just stop here, right? The actual animation as to how we got here is kind of more interesting than the pattern itself, but this pattern it's chaotic, but it looks substantially different from the other things we've made. So like as we're working on this program, we want it to be like a little recipe book where like everything we make is different, right? And so everything doesn't have to like be super cool or impressive. It just has to be different, right? So we know we put a whole bunch of zeros at the beginning so that we wouldn't lose our spot. And so we did the 33s at the bottom to move it around. So this looks like our recipe. Let's copy that. And let's go back into, where is our recipe.txt? Recipe.txt. This one is kind of a failed attempt, right? We're going to take this one here. We don't need those zeros. I mean, we could have the zeros in front of it just because, well, we really don't want that because then, like if we want, we could space things out with some zeros. Actually, we could do that. We could actually, that would actually be interesting because we could do, we could put zeros here to kind of visually mark things out. Oh, there's the 1281 there. I'm going to put some zeros here. And then there's another 1281. Where's the other 1281? I'm going to put, like, zeros right before the 1281s. So that there's a little bit of a pause before we do the normalization step. But we don't want to pause at the very beginning because that would just, no. Okay, so this right here, we're going to save that. We're going to go into the other program, which has either crashed or we closed it. I don't know. Okay. So we're going to go run this. And we're going to go put this pattern into, we're going to go import this pattern to PHOFace and just make sure that it gets what we think it's getting. And then we will, I don't know, this has been going on for almost 3 hours and we've been explaining the filters. We really do have to create the documentation strings for this stuff, and I feel like if I don't do it, on video, that I'll never get around to it. Also, why the hell is this still, like, not doing anything? Like, why is it taking so long to build? I think, like, sometimes I use my build script and, like, a hard drive has, like, hibernated on me or some shit, and so it's like, I'm just gonna freeze on you. Like, seriously, like, what is this bullshit? Okay, so we're gonna go to customize. We're gonna take this last slot. We're gonna go import. We're gonna go find recipe.txt, right? Here's recipe.txt. We're gonna run this. Now, this is not the same starting image, but I'm gonna use this image anyways because I just wanna see if it kind of does the same thing, right? Okay, so we kind of see the same kind of thing going on. And I just want to make sure that whatever happens, that it has a similar feel, right? Yeah, I kind of see a similar feel, right? Yeah, that looks kind of cool, right? All right, yeah, I'm happy with that. Now, one more thing, we might want to actually use the image that we used to the left to make sure it's an exact match, right? So we're going to go customize, we're going to go use this, and we're going to run this. We're just going to make sure that it's an exact match because the last time we, like, screwed something up and we didn't get an exact match. PHOFace is using PHOSIMP as like the rendering engine, so it should be an exact match. If it's not an exact match, then I got to reevaluate my life choices and make sure that I haven't lost my sanity, right? All right, that's pretty cool. Okay, yeah. So that is the same. That is the same. Good. Though I have to say my monitor is not very high quality because it looks slightly different because the angle of what I'm looking... Oh, no, that's not quite the same. This one is a little bit... Oh, there might be some transparency in this. Hold on. If we do 340, 60, or the transparency, is it going to, like, change? Why is that slightly different? That's not... How the hell is that slightly different when it's using the same... Huh. You know what? It has basically the same feel, so I don't think I'm gonna worry about it. I think I'm gonna go export this. I'm gonna do recipe.oo2.txt just in case I overwrote something or made some type of mistake here. So there are 40 steps. I don't know, that's... I don't like that it's not quite... there's 1281s in here. It looks pretty much the same. I don't... not happy. Okay. Well, you know what? It's good enough. It's good enough. But I am a little bit... meh. Okay. So... let's go find the source code for PHOSIMP here. And the next empty slot is 264. If we use 264, we want to make sure that whatever 264 is, it doesn't look cool, right? Because it's randomly generated bullshit, but there's always the chance that it might look interesting. Does it look interesting? No, it doesn't. We're going to nuke it, right? And then what are we going to call this, right? I don't know what we're going to call this. We'll call this finally figured out what filter 40 does, right? That's what we'll call it. Okay, so we'll go boom, boom, and boom. We'll close this. And we'll take this little marker here that we've had in our source code, and we will put that up. And then we'll say this is recipe 264. We'll call it finally figured out filter 40. And then we'll grab onto this to control F parkour up to the descriptions we've been writing. 264. Okay, so now we can kind of grab onto this, and we can get to, okay, we're going to recompile, and we're just going to make sure that what we've added is working, right? And so we understand filter 40 now, right? We understand filter 40, but we need to add documentation. Also, those operation codes we still haven't documented. We're going to go up to the top here. So we've been working on documentation for... oh, that's the wrong thing. Over here. We have been working on documentation. Okay, we put the documentation at the top. But as we've been working on this documentation, we started at like... Okay. What was the number we were working on? 1265. What does it say in PHOSIMP? We were on 1264. Okay. Oh no, 264. Okay, here's 264. And we just want to make sure that it's the thing we think it is. It looks like it is the thing we think it is. We'll run it, make sure that it does the things that we think it's going to do. And then we're going to close this. All right. Okay. So that's looking good to me. I'm going to close this. Okay, we've generated some patterns while we were working on documenting the source code. And we want to find PHOSIMP. Okay, so this is PHOSIMP. This is the JS version. We need the documentation strings in both. So I'm going to add the documentation strings for filters 0 to 40 before we end this video. But I am going to pause this video because I got to take a shower. I'll be back. All right, are we recording again? I think the hard drive. Okay. Okay, so we're recording. Okay, we're going to move over the C code and the JavaScript code to the same file. And unfortunately, when we do that, we do lose our spot, but it's not hard, right? Because we're going to edit the same code in both files, right? So we've named everything the same, right? Now, obviously, the syntax between C code and JavaScript code is different, but since we stuck with all the same identifiers, it's going to be, oh my god, my editor is freezing here. Because we stuck with all the same identifier names, it's going to be easy to find stuff. We want to explain filters all the way up to 40, right? So we want to explain filters 1, 2, yeah, anyways. This could take up to 400 minutes if we take 10 minutes per paragraph, so I don't really want this to take forever, but first thing we're going to do, we're going to duplicate this, and this has 1,000 whatever. It's not in the thousands, and this is filter 0. Filter 0 is actually a filter, and filter 0 is our do nothing filter. Okay, filter 0 is our do nothing filter. I really would like filter 0. We might want to change that in PhoFace. We might want recipe 0 to also do nothing. Oh no, because we changed the top and bottom shelves by hiding filter 0, then that wrecks a whole bunch of our logic. Oh, that would be bad. Is there any logical reason as to why we would want filter 0? Yeah, there is, because what if we want, like, we want to omit doing a filter step in... What if we want to omit doing a recipe step in other code and 0 doesn't mean a nothing recipe? Yeah, a nothing recipe actually would be a good idea, but we don't want to expose the nothing recipe in PhoFace, so we actually want the counting. Oh my god. Filter 0 is our do nothing filter. Okay, so we have a little summary of filter 0, which turned into a ramble because this can be at most 32 lines. So that does mean we can take some formatting liberty, right? So that means we could put a blank line here. So filter 0 is our do nothing filter, right? Okay, good. So we have an explanation of what this does. And then what we're going to do is, now that we have this explanation, and my syntax highlighting, you know, I use the syntax highlighting feature of Notepad++ very unconventionally, and I think that kind of like screws me over a little bit here, where it's like, oh, the syntax highlighting blew up on me again. It keeps on blowing up on me every 10 minutes or less, so, oh great, okay, let's fix that, okay. And now let's wait forever. Okay, you know what? I changed my mind. I changed my fucking mind about putting both of these in the same file, because not only do I not have a side-by-side, but then if one of the editors fucking crashes on me like that, I can't go into the other editor and keep on working. So let's wait for that to fix. And let's do const char pointer d PHOSIMP doc 2048. 2048 because it's 2048 characters maximum, I think, because like 32 by 32, I think. I don't remember why it's called that, honestly. Something like that. It has something to do with the capacity of the string. Oh, 32 times 64, that's what it is, right? Because the lines of code in here are 64 characters max, and so I know that I'm not going to exceed 32 by 64. We'll actually have to verify that by just doing some math. Like if we get out a calculator, right? 32 times 64. Probably, yeah, probably. Oh my god. Why is my recording overloaded? Oh, okay. Let's close. Do you want to close this? I know this takes up a lot of CPU. We don't need this open right now. And my recording takes up a lot of CPU. All my browsers are closed. Oh, why are there fucking advertisements in my Windows? Yep, and that is why. That is why everyone's gonna leave Windows once they're in a situation where upgrading to Windows is harder than installing Linux. Oh my god. Is this... Just come on, get over here. Okay, so 32 times 64, yes? 2048. There's our 2048. I was correct. Okay. So this is our negative filter. Okay. So as we're doing this, we can grab onto this and we can go find this. And you see this is the C code. And this is C code. So we're going to go take this C code here. And we're going to change it into JavaScript, right? So we see that with JavaScript, instead of the 32, it's just like this, right? And then with the end of it, it's like this. So on the ends, we do this. And then the third thing is it's no longer const char pointer, it's just const, right? It's just const and then the identifier. So bam and bam. Okay, so now that we have that, we're going to go on to the second filter, the filter number 2. And let's go run this so that as we're doing it, we can just verify that we're not typing bullshit. Why do I have like 3 fucking things open? Oh, because I opened this up in its own thing, huh? Not really what I wanted to do, but okay. Okay, so, filter, what the fuck? Okay, so filter 2 is like, what is it? Okay, multiply by 2. Multiply, and then the other one's divide. Multiply and divide. Okay, yeah, I remember. Okay, so Oh, that's annoying. And we can't change the order because it's Windows. Windows glues these fucking things together, and it's like they're on the wrong fucking side. What, right? The tab to the fucking left is the window to the right. The tab on the right is the window to the left. Fuck you, Windows. So what are we going to do about that? Do we just want to literally just change our windows just because Windows won't let us reorder the tabs on my fucking start bar, so we'll have to fucking physically do that. So now they fucking line up correctly. Jesus fucking Christ. Okay, so okay. So this is going to cause the image to get blown out, right? And we've already made some mistakes here. We have commas in front of this. Our C code will let us do this, but it'll just end up one big string, which is not something we want to do. But we have to make sure that we have the commas in front of this. Oops. Okay, then over here, same deal, where this is our JavaScript code. We will get a syntax error if we forget this in our JavaScript code. So let's and for oh yes, I see. No comma, no comma, no comma, no comma, no comma. No comma, no comma. Okay, so this one right here. And this is 3. This is the JavaScript, so there's no const char, it's just const. And then it has this here on the end. And then it has this here like that. Okay. And 3 here. So sometimes what I like to do is that the different part, I like to put in square brackets so that when I look at these two blocks of text and they look similar, I can see the difference. Okay, so divide every pixel will cause image to get what did we do wrong here? Negative, blah, 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 blah. I am being stupid. Multiply every pixel by 2.0 and then divide. Okay, so we have a 3 and a 3. Okay, I've been going for like 3 hours, and I don't know how I'm going to do this. I think we already kind of explained this. If we keep up this work session on camera, we could, I did the math, we could potentially end up going for like 4 more hours. And I really don't want to go 4 hours kind of making up the technical debt in the documentation. So let's make sure that what we've done so far compiles. Right, what we've done so far, let's make sure it compiles. And if it compiles, then I think we'll end the video, right? And we do want to end the video like making a cool pattern and also like summarizing kind of what we did. So we'll summarize what we did. We'll tell people to buy PHOSIMP on Steam, and then we'll get out of here. Okay, so this compiles, good. Okay. And we also want to make sure that the JavaScript code, nothing horrible is happening with it. So the JavaScript code here, full file path to clipboard, we actually need to open up like Chrome or something, right? We have to open up Chrome. I think both of these are like memory leaking massively on me. I don't know why, because they're stupid. Okay, so we're gonna go to the HTML page, or the HTML page, which is HTML, and we're just gonna make sure that we don't have any syntax errors that are gonna cause this to crash. Already, that's not looking good. So I'm gonna look at the debug tools. Content and available resources were not cached. Okay. And this is still doing something? That's not good. Console, what is the console? Missing initializer in const declaration. Okay. Let's go refresh this again. Console. Okay, so basically as we were working on this, our refactoring between the C code and the JavaScript code was not correct. And we can already see what that is, right? It's this thing right here. So let's get rid of that. Let's go over here, let's refresh that. Okay, so we got some little error messages. But I believe those were to-do messages. Oh, we have a little note here. Transcribe from C code when ready. Okay, that is actually fine. There's some so if we go like grab onto this, we write the C code first and then we write the JavaScript. So if I look for this error message, right, this code has not been written yet in JavaScript because we want to finish it completely in the C code before we port it to JavaScript. That's fine, that's fine. Everything is syntactically okay in this file, I'm convinced, so we can move on from that. Okay, so before we end the video, we do want to summarize the filters that this video is about, right? Because this is supposed to be a video explaining filters 31 to 40. And we know that like people aren't really going to watch this documentation. We know like a lot of people are asking for documentation, but we know that these videos are not really going to like make us profit, right? Like, so we want to not completely waste our time making things that aren't going to give us profit by actually doing a work session as well. That's kind of like why things are the way they are here. Okay, so we want to explain filters 31 to 40. So let's go over them all again. All right. So 31 is just moving the image in one direction to the left. Okay. 32 moves the image other way, right? 33 moves it up. Okay. 34 moves it the other way. Now 31, 32, 33, 34, these are actually software filters. It is actually changing the image. There's not like some viewport that I'm panning around. It's actually changing the image, right? Okay, so let's go on to 35. Okay, so 35 is a Space Invader filter. We explained how that worked earlier in the video, at the beginning of the video. 36 is a Space Invader filter. We talked about that at the beginning of the video. 37, another variant of the Space Invader filter that tends to make things pixelated when you use it more than once, okay? 38 is, I believe, the last Space Invader filter variant. Or no, 39 might be, right? Because we got stuck on 40, right? 40, okay, 40 is the last Space Invader filter. And then, 39 is the last Space Invader filter. Then 40 is the filter we got stuck on, right? 40 is this halftone bounding boxes filter, right? So we know that this filter stamps a whole bunch of colored squares on top of the pixels if the pixels are within the visible spectrum. If the pixels are outside of the visible spectrum, then it starts to stamp square wireframe rings around the center point of the pixel. And it does it color channel per color channel. So it's not actually analyzing every single pixel. It's actually doing it channel by channel. So that means a pixel can both be within the visible spectrum and without the visible spectrum at the same time. It can be in the visible range and outside the visible range, because maybe the red is between -1 and +1, but the blue is like 1 million, and then the green is like -1 million, so only the red color is within the visible range, right? So when you stamp red, you stamp a red square, but when you stamp green and blue, you stamp a wireframe rectangle because it's an out-of-bound color, right? So we know that 1281 is like a tone mapping filter that can bring things back within range, which I think is kind of fun. And then I wonder if I use 1281 again, I don't think it'll do anything, but let's do it again. Okay, nope. Let's use filter 4, and then 4 again. I kind of like that right there. That looks pretty cool, right? So how did we get to where we are with that? I see that there's a Space Invader filter here, but then when I look at my logs, I'm like, why does this say can't compare that way in C? There's no Space Invader filter here, but there's Space Invader filters here and other stuff here. At what point did we actually reset? And I don't actually know. And that's kind of frustrating, right? I'm pretty sure we did the Space Invader filter a whole bunch of times, and then we reset, and then Space Invader filter a whole bunch of times, and then reset, right? So I will copy these. This is where the Space Invader filters start. I'm going to copy this from the logs really quick, and then I'm going to put this down here. I'm just going to make sure that we have that. I think what probably happened is I think we probably did 39, 1, 2, 3, 4, 5, 6, 7 times. I think we did 39 that many times. And then I think we put like 40 on top of it, I'm guessing. No, that still doesn't look correct, right? Oh, I know what happened. No? Maybe. I mean, that actually does... Oh, we have a bug. We have a bug, don't we? So if we do 39 and we go reset, and then we do 40. 40 on top of this. Okay, what about 40 on top of that? Yeah? Is that all correct? Okay, what about 39? Reset 40. Oh, that's 30. Okay. 39. Reset 40. Oh, there it is. That is a bug. That's, oh God. How do I know it's a bug? We reset. Okay, so we go 1281 here. We can obviously see there's that texture, right? Now this is cool and all, but that is a bug with the double buffering. That is not good. Fuck! I thought we solved this. Okay, so if we do 40, once again, that reset, 40. Right, that's not the same thing, is it? So if we do, let's make it obvious, right? If we do 16, we reset, and then we use 40. Interesting. It's not always consistently glitching out, right? What about if we use 40 again? Okay, so 16, 16, 16, reset. Ooh, we have to get on both double buffers, right? Is that what's going on? Okay, now we see that kaleidoscope. Okay, I see. So if we do 1,111, 1,111, we do that twice, then we reset, and then we use 40. I can kind of see it in there. If we use 1281 to tone map it, we can probably... Okay. So something is wrong with... Okay, so we know something's wrong, and we know that there's like one after image in the back buffer. So chances are to recreate what we created properly is probably going to be like 3940 and 1281, kind of, right? And then we put like a 4 and a 4 on top of it, right? And still, that's not quite it either, right, is it? So we could do like a 38, a 39, okay, a 40 on top of that, a 1281 on top of that, 1281 again, even though we don't think the two 1281s did anything, but that's what's in my notes. That's kind of closer. Do 37 on top of that, and then we could do 40 again. 1281. A 4 and a 4. Yeah, I don't know how we're gonna get that back. So what about if we do like a 40, a 39, a 38, a 40, another 40, that's not a 40, another 40, 1281, a 4, and a 4. Huh. I don't know. But there definitely is something weird happening with this buffer here, right? Like that right here, that has something... 40 itself has a glitch with the double buffering. Can we fix that? So... it's probably stamping to the it's stamping to the back buffer, but it needs to copy over the image to the back buffer first, and then it needs to stamp, and I don't think that's what it's doing. So okay, these buffers here we have to keep track of. And there's probably a helper function here. Okay, so we get stuff from the front buffer, that's fine. Clamping out of bounds selections, modulating. This helper function, let's make sure that this helper function does not actually access the double buffer in any way, because it could. Okay, it's getting H1 here. This is the destination buffer. What is it doing with H1? Is it writing to H1? It is writing to H1. Okay, so we know it writes to buffer H1. That's fine. That's fine. It's not a problem. But if we want consistency, before we write to buffer 8, okay. So for this to be fixed, okay. So we want to copy H0 to the desk. Okay. I didn't think that we were going to be like having a code fixing session here, but this could change some recipes that are using filter 40, right? And change them for the worse. So we'll have to like review some of the recipes that we made today. Um, Okay, so we have a little bit of a ramble about how we're gonna fix this. Now usually if I have a bug in a filter, I would say, okay, that's just the way the filter works now. But this wrecks the stateless transformations, right? It's remembering what happened in a previous filter, and what happened in a previous filter is affecting the next filter. We can't really have that. So we have to fix this. So what we're going to do here is we're going to make a temporary scope so that we don't have to worry about what all these other fucking variables are. And we're going to say in32 and this can be, we're in the C code. We're going to make a const in32 HDR buff height. And we've probably used a variable like this somewhere else in the source code, but probably not this specific function, right? Yeah, we're 102,000, 110,000. Yeah, okay. So so we're gonna get the width and height, and then we're gonna say constant 32. I don't know. I just want it to be different than what we've used in other places. Okay. Okay. So HDR max XXX, probably not a variable used anywhere else. Okay. So what we want to do here is just say that for we'll just say like HX, HDX, that almost fits. I mean, we can crunch that together. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, something else. Okay, so right here, we want the y on the outside of the loop, right? So y before x, because we want to go row by row in scanline order. We want to make absolutely sure that the y's are all the variables here, and then the x's are all the variables here, that we're not mixing and matching, right? So width, and then, is that correct? Yeah, width is x, y is height, width and width, width and width, height and height. Just make sure we didn't transpose anything. And then HDI equals HDX plus HDY times HDR buff stride in pixels. So then over here, we need another const in 32. HDR buff stride in pixels. Get HDR SIP is stride in pixel. This is just an alias. Stride in pixels is really just an alias for the width, but I don't like the asymmetry of that. So I have this variable just to make things less asymmetric. Stride in pixels times y plus the x gives us the index, right? So HDR index, and then HDC, which is the HDR component, equals 4 times the HDR index, right? And then what we can do is we can just say that H1 HDC plus 0 is going to be equivalent to H0, the input, HDC plus 0. And I'm going to kind of reformat this until it's to my liking. I don't know, it's not the best formatting, but we have this on this side, HDC 0 for red, green, blue, and alpha. Usually I'll use constants for this, but I'm in a pinch. So, okay, so source, and this is the destination buffer. Okay. Okay, so now we have this. I think that code is correct. I could be wrong, and we might be transcribing it a little bit too soon. But these things need to be const now because we're in the JavaScript code here. Now the H0 and the H1 were gotten up here, right? H0 and H1 were gotten earlier, so we don't have to worry about that. It looks like HS is for stride with this S, so we've gotten the stride again with this other thing. That's fine. That's why we put, oh, that is why this thing that I forgot. That's why we're putting it in its like own scope so that we don't have to worry about collision with these new things we're declaring just in case, right? So that's what that temporary scope is for. And okay, I think that's good. Now we need to describe what we're doing here. So I'm going to go down here, and we're still kind of working on this stuff here. Above, blah, blah, blah. Okay, so that's my explanation for what's going on there. Okay, so now we're going to go down to the bottom of the file of both of these files, and we're just going to add that footnote to both of these. Control F parcore up into the C code. Here is our new C code. And then Control F parcore up into the JavaScript code. Here's our new JavaScript code. Okay, so we want to recompile this, and we just want to make sure that, first of all, that it compiles, that we didn't make any stupid syntax error. Because if we did make a stupid syntax error and this does not compile, then I guarantee we made the same goddamn mistake in both files. And I see what we did. We forgot to declare these kind of other things. So I'm going to be lazy, and I'm just going to say, like, int32, hdx, hdy, hdi for index, hdc for component, right? So x, y, index, component. I write variables like this in my code like all the time. So this is going to be a let. Okay. So now, do we want to align this a little bit better? Like put that like just a little over there like that? I don't know. Maybe we're being a little bit OCD now. Okay. So now, let's close this. And this is the PHOSIMP code. So we made the change to both files, so I have confidence that if this compiles in the C code, then the JavaScript is also correct, right? So what we're looking for is just hoping that this gets rid of the side effects. Not only does it get rid of the side effects, but it also has to not like do something like if we get something totally erratic, then we're still in trouble, right? Okay, so we're gonna go reset, and we're gonna use filter 40, okay? Filter 40, that looks correct to me. Good. Now, we know that when we're doing like 36 and 36 and 36, and then we reset, and then we used 40, we're getting that weird texture in the background. Are we getting it anymore? No, we're not getting it anymore. So I think I solved the side effect issue that we were having. Let's go 36 and 36 and 36 and do 41. Make sure that 41 isn't doing any weird side effects. 41 doesn't seem, ooh, Jesus Christ. 41 is getting side effects too, right? So we see that 41 here. The whole accumulator logic that I was using, yeah, 41 has side effects. How do I know? Because you can see the Space Invader, right? So if we reset and reset and reset, and then we do 41, 41. No weird Space Invader thing. That's kind of what I expected, right? We can do filter 0, which is the do nothing filter to clear out the buffer. Then we can do 41 here. Okay, that's kind of what we expect 41 to look like, right? But now if we do 36 and 36 and 36 and we reset and then we use 41. Okay, what about 36, 35, 36, 40, nope. Okay, reset, 41. Okay, nothing. Was it a combination of 40? Okay, what if we do 40? Okay, what if we do 36, 36, and we do 40? Okay, then we reset. We just did 40, and we're going to do 41. Okay, no side effect. How the fuck did that happen? Okay, 36 once, reset, 41. Okay, 36 twice, because the buffer is a double buffer system, so doing odd or even could change the outcome. Reset, 41. Okay, no, that's still correct. 36, 36, 36, 41. Oh no, maybe I just did that and I lost track of what I was doing, because I remember seeing exactly this earlier. We could go over the recording footage, but we're never going to do that. Okay, and then 1281, and then 4. Okay, what about 1281 on top of this? Can we bring stuff back? Oh, we can, kinda, but it's not... It's just kind of noise at this point, right? Like, we can do 1281, and it'll bring stuff back, but it's just noise by now. That's interesting. 40, 1281, right? 40, 1281, 40, 1281. That's an interesting cycle we got going there. And then 41, 1281, bring it back. Oh damn, we lost that one. Okay, so let's do 41 and then 40. Do that one more time. Well, then it's just 1281 on top of that. Let's put a gradient ramp. 40, 41, 1281. Okay. Let's do 1111 to kind of mirror that. Let's do 41. And this is making me think that we lost everything. Oh, we got a little cellular automata thing going there. 1281. Anything in there? No, nothing's in there, huh? So something's happening where sometimes you do, sometimes you just lose stuff, right? Sometimes you just lose stuff. Sometimes you lose information. 1281. Oh, that's kind of cool. I would like it being a different color though, right? I like the little scan lines. Let's do an 18, a 19, put a gradient ramp on it. Let's do a 40 on top of that, 240 on top of that, 1281 on top of that, and then colorize that. Then can we do 300 and 311 on that? And let's do a 1281 on top of that. And we need like something that it's very pastel, probably because these are their darkest parts, huh? The tone mapping could be better. For sure. We could put a gradient ramp on it. That gave it a little bit more color. I kind of like that. Okay, so what do we have here for that? I know we kind of messed around for a bit. I don't know if this is going to get... Here, let's copy it. And I know we're like, oh, we're going to stop putting random stuff in the code. We're gonna be done soon, right? And then it's like, nope, I'm over here messing around still. Okay, let's put this over here on this side of the screen. And let's delete all this. Let's paste this new thing that we think might be doing something, but we don't actually know. Okay, and then get out our build script for PHOFACE. And we want to We'll want to run this new recipe and see if that actually... We really need to work on, when we press the reset button, we should probably add that back in right now. When we press the reset button, we actually want to see the reset, right? So this says reset right here. Yeah, we're going to have to work on that because it's very annoying not to see it, and I heard other people complain about not being able to see it. Okay, we're going to go customize. We're going to go import recipe 2. Oh, I made it. Oh my god, recipe 2. Okay. Recipe 2. Okay, run it. Okay, so we're running this on... Okay, I remember where things kind of got blacked out. I do kind of remember that, but we're missing something here. We're definitely missing something here. Now, there was intentionality when we made this, so I guess, like, if we still get something that looks cool, then we'll call it a day, but I don't know. I'd say no. I'd say that looks like trash. Now, I am curious to see what it would look like with this image, right? Because maybe we actually have something cool. It's just that it's very different with different images, right? Like, that could be a thing. Yeah, that's kind of what it's looking like, huh? Where it's like... Yeah, because I remember this is much more interesting already, right? Uh-huh. Yeah, that's actually what we expected. Yeah, that's actually... Yeah, that's exactly what we expected. Okay. Can we make that more consistent? Can we do like a 1281? Can we do like a 190 1281 at the beginning? Let's put some other 0 slots. 1, 2, 3, 4, 4, 5, 6. So that we have a whole empty block here. Oh no, that goes past. That's fine. We can get rid of the moving it around. Okay, so let's go back and let's go import recipe 2 again. Let's go run it. Okay, so we did some color correction at the very beginning, which is going to totally change things, right? So this pattern could look totally different, but the question is, do we still have something interesting? And after we get something interesting, if we do get something interesting, will it look interesting with the other photo, right? That's the thing I'm worried about, is that, like, if we put different photos in, do we just get totally different stuff, right? Okay, so that still, it looks different, but it still looks kind of interesting. Now the question is, if we go load the other image where we just got complete crap, right? Do we now get something interesting? Does that color correction step lead to more interesting results when we do different inputs, right? Does it make things a little bit less chaotic, or at least like have more interesting stuff happen? Because we remember when we did this earlier, it was complete shit, right? It was like just a square box basically. So now it looks like that color correction step with the normalization is actually making some cool stuff happen, right? I think that's pretty cool. Okay, so now let's make sure we didn't get lucky, right? So because we know that we have something very unpredictable on our hands, we are going to try it out a few more times, right? We're going to try it on 4 different images. Uh-huh. Mm-hmm. Okay. Okay. So one more, because we have one more, right? We have this, so let's use it. We're going to go to customize, and we're going to use that recipe one more time. So yeah, in order to, like, if we make something and we find it's very chaotic, one thing we can try to do is we can try to normalize the color somehow at the very beginning of the recipe so that the outputs are less unpredictable, right? And that's kind of what we did with the 190 color correction and the tone mapping here, right? So we're still getting different images, but now all the different images actually look really fucking cool, right? So we got this new recipe, recipe 2. We're gonna go back and we're gonna go hit export. Instead of overwriting recipe 2, why don't we just name this recipe.txt, replace it, yes, and let's close this. Don't know what it is, don't care. We modified this, okay. So now we can take all of this, and we are going to keep the zeros, right? We have a whole bunch of zeros here that do nothing, but that's because I left that so it would be easier to edit the recipe. So like if you want to edit this recipe, I left you some blank spaces where I thought it would be nice to have blank spaces, right? So we're going to take this and let's put this on our clipboard, and then let's go into PHOSIMP, yeah. And then 263. Let's go to look at 263 and make sure that 263 isn't something that actually looks cool, right? 263 is also random numbers, so let's see what it does. I've seen this pattern multiple times. I'm not really impressed. Yeah, not impressed. It does look cool though. Like I do feel like we should mess around with that, but it's not interesting enough to keep. Okay. What about 262? Like 263 is interesting enough where I might want to jot down the notes and use it as a base for a pattern, right? Like, but I'm not super interested in it, right? Okay, we're gonna take these numbers and we're just put them over here, and we might forget about them, but it's okay because it wasn't handcrafted, right? Okay, so with these numbers, we're gonna get them into the code. I know I'm keep on being like, I'm gonna end this video, I'm gonna explain this stuff, and then I explained it, and then I'm like, we're gonna end the video with a cool pattern. And then what happened? Well, what happened was we were like, oh, we're gonna end this video with a cool pattern. And then as we were messing around, we're like, oh crap, there's a bug in our code. Let's go fix that bug. We fixed the bug, and then we're like, oh no, we're no longer ending the video on a high point by making something interesting. And then we got distracted and decided to film the footage of us actually embedding this filter into this recipe, embedding this recipe into the source code, right? So this is recipe 263 fixed bug, and then color correct. I'm gonna call it color corrected clown barf Mandela. Okay? Is it Mandela? I don't know. But that's what it's called now. Okay, we're gonna Control F parkour onto this. Two, 6, 3. We'll call it Clown Barf Man because we didn't have room to write Mandela. So people will be like, Clown Barf Man, what does that mean? Right? And it stands for Mandela, not actually man. But people will think it stands for man, but it actually stands for Mandela, right? Sure. We could say color fix. color fix clown barf MDK scope, where MDK stands for Mandela Kaleidoscope. Right? And then we might want to, we're going to not know what MDK means in the future, so we'll just say at MDK. So Mandela Kaleidoscope scope, yeah, whatever. Okay, so we do want to make sure that that is built into the code properly, and that we actually get like this interesting effect. We know it's not going to look exactly like this because we did some color correction steps so that the output would be more consistently interesting with different image inputs, and that's fine. And then after we look at this, make sure it's embedded into the source code correctly, what we're going to do is we're going to explain filters 31 to 40 concisely again, make something cool, and then get out of here. And then if somebody's like, oh my god, I can't find the explanation because it's stuck in a 4-hour video. I explain these filters so many goddamn times. Do not say that to me. All right, our recording is almost 4 hours long. The stakes get higher and higher the longer this recording goes, because if we crash, then we lost all this video footage. Okay, so 263, let's make sure that 263 is making the cool thing. So it did some color correction at the beginning, and then it does this very chaotic, unpredictable thing, but the chaotic, unpredictable output is a little bit more predictable because we kind of did that color normalization step at the beginning, right? Okay, so far, looking at it, it's looking good, right? It's chaotic and ugly, but whatever. Okay, cool. So now we want to end the video on an interesting point. So let's explain filters 31 to 40 like we promised, right? So 31 pans in one direction, 32 pans in the other direction, right? 33 pans in the other direction, 34 pans in the other direction, right? 35 right here is a Space Invader filter, 36 is another Space Invader filter variant, 37 is another Space Invader filter that also seems to down-res the image when it's used twice. I don't know why that happens. We're not going to get into it. 38 is the another Space Invader filter variant. And then 39 is the last Space Invader filter variant that we have. We see that when we use this one a whole bunch of times, the image kind of devolves into white. Then 40 is our weird filter that stamps a whole bunch of square boxes of color on top of pixels and adds them all up. And it only does that when the pixels are within the -1 to +1 range. Now, when the pixels are outside of the -1 to +1 range, it stamps wireframe square rings at the center point of the pixels. So because we've just used this filter once and stacked up a whole bunch of boxes on top of each other and added them all, the sum has exceeded the visible spectrum, and that's why this image seems super blown out, right? So if we use this filter one more time, instead of stamping nothing but squares, it's going to stamp basically nothing but wireframe rings. Now, the third time we use it, some things are going to end up in bounds, some things are going to end up out of bounds. Like in this image here, there's some pixels that are probably in bounds and some that are out of bounds. So if we use it a second time, there's going to be a combination of squares and wireframe rings, I think. And I'm actually surprised that this didn't get back the original image. Oh my god, oh my god! We fixed that bug, right? We had this bug where, like, when we used the filter 3 times in a row, we got back the original image. That was a bug because of the side effects of the filter. We don't have that anymore. That's interesting. Okay, I kind of like that right there. That's a nice face filter right there. We should put that into the software, but we'll put that in the software off camera because we've explained all the filters. And I'm out of here. Buy PHOSIMP on Steam. PHOSIMP is only 99 cents. PHOSIMP, 99 cents on Steam. PhoFace, also 99 cents on Steam.